All right, I think we're ready to go here. Let's make sure the sound's good, make sure the closed captions are working. Looks good. All right, so we are going to go through today a little bit on monitoring. We're doing labs. Sundays are all lab days, right? But I got asked to talk through a topic of monitoring. Somebody asked on YouTube, and I just kind of go with whatever I hear that you guys want to talk about. So this is what we're going to do. We're going to do some monitoring, specifically around Linux systems. If I look tired, even though it's almost noon here, I am. We had a party last night, and show you guys some stuff with the party here. We had the Epic Game trailer out. I'm sure some people find that interesting. And if you wonder what an Epic Game trailer is, they are, well, this is, the kids were coloring on the sidewalk, and then that was more of the kids and family coloring on the sidewalk, and then that was us riding the drift trikes. Some of you guys have seen the drift trikes before. We back there, and we were cruising around on the drift trikes. We got a nice cul-de-sac in the area, so we can do that. And then that's the inside of the game truck. There's a bunch of games along the wall, and then the kids can play them and stuff, so it's kind of a fun little thing. So I thought I'd show you guys that, because that's, you know, had a bunch of people over, had some fun playing around with that kind of stuff. But now it's back to serious time. So we're going to do some monitoring deep dive stuff, go into some labs on working on the systems, and that's what we'll do. We'll get through what we can. And yeah, looking good. Looks like my stream's going on both sides, so that's good. All right, if you have questions, let me know. Otherwise, as we go through this stuff, we'll work on all the pieces. There is one other thing to show you guys here with what I'm showing you, because this question always comes up. We have this Prolog projects folder, and everything about this monitoring is in this folder. So there's the monitoring deep dive project guide and the monitoring deep dive with labs, right? So you need both of these. One is the presentation that I'm going to go through, and the other one is actually the project where you'll fill out, and let's say you have nothing else on a resume, you could at least have, I know how to build out this monitoring stuff. So it's a thing that you'll fill out almost like a template. And actually, I'll show you an example of that here as we go through the labs. All right. So it's, you know, this is for fun, but it's also for profit, right? We could go and use this kind of stuff to play with our home labs. We could use this stuff to hopefully find ourselves a job out in the field somewhere, if we're interested in doing this kind of stuff, right? That's the goal of this group, is to get you guys into doing this stuff professionally. So the things I'll be pulling up will be the deep dive guide. Here's the guide over here. And the guide will have questions and purpose and some other stuff. And I've got some pictures that are already stuffed in there that you could use, or use your own, right, as you kind of go through these labs. And then the other thing I'm going to do is I'll be linking the labs as we go. So we'll have labs over here. And the labs actually start down here in the, I think the 100 range, wherever this is here, 101, 102. But I'll link them to you as we get to each of the labs. So as we go through the presentation or whatever, you'll see all the labs pop up. All right. Other than that, I'll kind of just talk through what's going on in the guide. If you guys have questions, let me know. If any of this stuff kind of resonates with you and you want to study it more, there's all kinds of resources down in the Discord for you guys to play with this stuff. Also, one other thing, in the Discord are some of the blocks of code that we used. So there's some things that kind of we talk about in the lab, like in this case, this is our writing out to Loki so that we could just send logs. So if you don't want to send logs to like a local logging file, you could write something to send them out to Loki. And I think the blocks of code for all that is right here. Yeah. So, you know, as we're going through the labs and you see things and you're like, oh man, where's he getting that from? I'm pulling it out of the Discord, right? I don't have it all stuck in my head, but some of the stuff is here. Some of the stuff I have in some of our local servers. So that's our write, and here's our InfluxDB write. And then you just have to change some of the values to work the way that you want them to. So then you can write to the different time series databases we're going to have, and also to the Loki endpoint, which is just a API endpoint to throw events at, really, you know. Okay. So monitoring deep dive, right? So this is our thing. Here's some quotes to get you interested. If you can't measure it, you can't manage it. That's a guy named Edwards Deming. If you don't know who Deming is, that's fine, but he was the kind of guy who, after World War II, he went from the U.S. over to Japan, and he helped them rebuild their country. He is considered one of the early founders of like the total quality management TQM movement. He had a bunch of what they call Demingisms, and one of my favorite things that he ever said was, if you can't describe everything you do as a process, you don't know what you're doing. And I really think that that's a pretty good way to look at like how you do things. If you're just like, oh well, during the day I do a little of this and I do a little of this and I clock out for the day, and you're like, I don't think you know what you're doing, right? Like, so he really helped me. His thought process helped me to think through like things that I do as an engineer, because again, engineering's got a lot of chaos involved in it. So we try to minimize that down. And then Peter Drucker was kind of a big businessman here in America, and he said, if you can't measure it, you can't improve it. And I agree with that. So if you can't, fix and figure out how far something is, you can't improve it. I say the same thing when I show you guys how to take a system and look at it and then make a change and then remeasure it. If you can't measure it, then how can we verify the delta of improvement or degradation, I guess? Like, how can you tell me that it got better if you can't measure it beforehand and measure it afterhand? That's all right. So anyway, so then Dutch from the movie Predator, if you've ever seen Predator, he said, if it can bleed, we can kill it. And that's pretty profound, right? Like, if something has blood and it needs that blood to work, right? So anyway, so that's when they were fighting the Predator in the old, I think it's like an 1987 movie. Pretty old. All right. So anyway, so these are quotes to get you interested. Let's talk about, here's the topics, what we're going to go into. We're going to talk about monitoring system. There's telemetry, which is metrics at a distance, right? We're gathering metrics on servers. Logs, we're gathering discrete events that happen, and they should be discrete and immutable, meaning they don't change. Yeah, we can transform them and put them in other ways and look at them, but the original record does not change in a log ever. It's important. And then tracing is kind of the flow of data through a system. You got a front-end web tier, and then a logic tier or an app tier, and then a database tier. You've got these 3-tier applications. How is the data flowing through there? How is it coming through and hitting your front-end web and then getting tied back to maybe through like some kind of sticky sessions back to the right application pod or whatever? And how do we track that? So tracing is that. So there's a lab on telemetry. We're going to do Python, Telegraph, InfluxDB, and Grafana. That'll take about 60 minutes. We may take more or less time in some of these. We'll write out an alert to Discord for the usage of a high system. The Discord URL that I have, the webhook that we use, it's still there in our Discord, but it's not included in this presentation. So like the thing that you'll see won't be the actual one. And that's just so that people can't just write into the Discord. But people that are doing the project with the group absolutely can. So writing and reading data with Python. So we'll do all these things, right? We got a lab on Loki. We have a lab on tracing with Prometheus and Node Exporter. And just looking at trace data from an application. In fact, in this case, we really... The tracing part isn't super deep. We're mostly doing the metrics and the logs, but the tracing data, I'll show you guys some things to go spend some time with if you are more of an application side guy and want to do that kind of stuff. But you can get a lot with the telemetry and the log part. The tracing part is a little weak in these labs because I didn't get around to the last part of it, but that's fine. We'll get through what we get through, right? All right. Terminal course objectives. So I always do these for my projects. I do these for my college classes and stuff. But it's like, when we're done with this, you should understand what types of data we monitor, which are those 3 I just mentioned, and we'll talk about them here in a minute. We'll want to know why we monitor data, right? As systems administrators, we use the use methodology, which is utilization, saturation, and errors. And I need to track those 3 things because with use, I can very quickly figure out what's happening inside of a system, where things are breaking. So there's that kind of stuff. Also, I just heard my voice. Am I like very tired sounding? Because I feel like I still have like sleep in my voice or something. I don't know. But anyways, how do we monitor data? So everything's going to end at Grafana. And that's one of my favorite things about systems like this is everything in our system can just end at Grafana. So then all we need to do is, how do we get Telegraph to feed data over into InfluxDB? InfluxDB is a time series database. PromTail to feed data into Loki and hitting an API endpoint. And then what if we didn't want to use PromTail because we didn't want to use a log? Again, we wanted to write an application. I'm not an application guy, but I've worked with hundreds of teams over the years like that would, come and ask me for the software, the platform engineering help, but they needed help to do whatever. So the logging of their application might be something they need help with. So I'll show you guys how to do that, right? That'll be part of having just an API endpoint that you can throw data at. That's important. Configuring an app with Prometheus and sending in this case, we'll do Node Exporter. And Node Exporter will squeeze up a bunch of information about the server and just expose it as a web endpoint. And then Prometheus will come along every 10 seconds and poll it. P-O-L-L. Yeah. Do you got any data for me? Do you got any data for me? And it'll grab it. The reason I mention that like that is some of these are going to be push and some of these are going to be pull. And you say, well, why does that matter, Scott? Well, one is if it's a push model, right? If it's a push model, we need to know, can it batch? Can it send data if the link is down for 30 seconds? Or if it's a pull model, what happens if the data doesn't get pulled? P-U-L-L in this case. What if the data doesn't get pulled for 30 minutes? Or if the node is down, or if the collector is down? What are the implications of things between these? Because that's going to make how we decide to collect the data, and how reliable we think the links are and all those kind of things. That's all going to come into it, right? So there's a lot of stuff with this. A lot of this stuff can get extended. So some of the stuff with like Telegraph and Influx, I'll show you how other companies that are out there like Wayfair did a cool project. I'll show you where they use Telegraph to InfluxDB, but they had disparate sites and they were worried about that problem of connectivity and being over WAN links. So they introduced Kafka to the mix. So Kafka is always ready to write, right? Kafka was a Russian writer who he died in his early 20s, but he had like over 30,000 short stories. So the thing is, the reason the name Kafka was picked is because Kafka's always ready to write. So Kafka is a system bus, right? It is a place. It's a publisher and sub model. So it's you publish things and then you read things out. Publish things, read things out, and it's almost like just a circuit train, or like a for people that live where there's subways. It's like a subway train that just goes around, and you can just throw data in there. So then you can pull it out at some other endpoint, and it becomes really useful. And I'll show you guys the Wayfair model and that kind of stuff for that. They have a nice blog post on that. So these are the things we're going to do. We'll build a dashboard for Grafana for each of them. And then, as I said, you should be using the project guide. If you're doing this with me, if you're like, I'll figure it out, I'll do it with them, then you should be taking what you're doing and writing the things into the project guide so that you're learning as you go. I'll have the project guide up as I'm doing the labs. It's also in the Discord, like I mentioned, but it looks like this. Okay, I'll pull this up in a second. And then how we alert on that data, sending an alert to Discord channel via webhook, those kind of things, right? And if any of you are in the Discord, or if any of you have joined the Discord, you know that I send stuff to the Discord, not all the time, but every morning we get an update on who's been in the servers, right? Who's been in our lab servers. We get an update on whenever my primary box reboots, which doesn't reboot very often, but when it does, it always sends an alert out to Discord, so everybody knows that the main jump box that I use has rebooted. I used to do that because when I would travel, I wanted to know if my server was ever rebooted, because it's not the only type of indicator of a compromise, but it's one of the primary indicators of somebody having written something and wanting to restart your machine to get it to run and those kind of things. So one of these things that we look for, right? So anyways, the point is see the data, right? So our intro to monitoring. So we'll talk a little bit about it. What types of data do we want to monitor? Why do we care? There's logs. Systems and apps are generating logs at all times. Some of you guys that have written any code or written any kind of actual application, it's like write meaningful logs, make sure the logs are when things change state or when they transition in some way, like log out at different levels of verbosity to somewhere. Because again, much like I always tell you guys, when everything works, we don't care. When everything works, when I just turn the truck on and it starts, I don't care. But if I turn the key on the truck, one of my friends was leaving the party last night and his truck wouldn't start. But it was like, so we knew there was something wrong. So I backed my truck out, and then we jumped his truck, and it worked just fine, right? But the point is, we went to troubleshoot his truck. We went to try to figure out what was wrong if it just all started. And it's the same thing with logs. Logs give you, everything's good, all quiet on the Western Front, whatever you want to say, everything's good. But if something's bad, we need to have good logging giving us information about the system, right? And then we need metrics, right? A numerical assessment of the system or application performance and resource utilization. So how is the system being used? What are the numbers? And then we break those down into what I was talking about earlier, the utilization and the saturation of the system. Is the system fully utilized? Is it saturated yet? And then are we starting to get queuing and then seeing timeout errors and those kind of things? And then traces are a little more complex, but it's how is data moving through the system? So you get the front end, you hit the load balancer. The load balancer is either something, up in the cloud, some third-party tool that's running load balancing for you, or some people just round robin DNS, which is an effective load balancer, but maybe it can be a little lagging because maybe it's just checking that the endpoint is live before it calls it good in the DNS table. So there's that kind of stuff. But then there's also, that data comes in and it hits maybe our load balancer, and then we've got some process for it, and then it's going through and it's being forwarded to one of our application servers on port 5000. Is that application being fed a good API call? Is the header information look right? Is the JSON body information good? Like, all these things are there that, we need to be able to troubleshoot them between all these links and stuff. So that's what trace data is. Trace is how the data is moving through the system and being able to go and look at it holistically. Like it's one call to a user. They hit a web endpoint and they want to buy sneakers, and all this other stuff's happening behind, but where is their actual call going through the system? And then that app is going and hitting a database. Is it reading the right files? Is it hitting a database is it pointed at the wrong, like it's pointed at the dev link instead of being pointed where it should, and like all this kind of stuff, right? There's all kinds of things that can go wrong in a system. In fact, there's so many things that can go wrong in a system that it's impossible to categorize them all. Like I tell people all the time, like as an engineer, I have no idea what I'm going to be doing today. Like, well, today I know what I'm doing. I'm going to be building some systems out later for a contract I'm working on, but other stuff, like I don't know what I might be troubleshooting or what might break, so I need to kind of understand what's out there so it makes everything easier to see. Srinath said, excellent, love from India. Can you make sessions on how to install Prometheus and Grafana to monitor Linux? We're doing all that today, Srinath. Yeah, we're going to install Prometheus and Grafana. Yeah, absolutely. That's what we're doing. It's all labs on Sundays. I'm just kind of prepping you guys up a little bit for it. All right, so let me pull this up real quick. In the home lab here, I have stuff that I monitor, right, in the home lab. Speaking of monitoring, so here is our systems. I have all the uptime of my servers, the servers that I care about. Here's their uptime. They're getting a little long in the tooth here. I need to patch them up and get them rebooted, but I have that. I can see the number of users per server, so that's a metric that I want to keep track of. This is a telemetry or a metric, right? It's tracking at any given time how many users were logged into any of my servers that I cared about, right? Over here, I've got utilization of the root drive for all of these boxes, and I'm mainly seeing, am I ever approaching 100%? Because if I get 100% utilization, then I have saturation, and actually in disk space, you're just out of disk space, right? Network storage is the same way, but over here on server CPU, I have all the servers that I care about and how much of their CPU is being utilized. And then I go up into the yellow and red up here. It looks like that's backwards, but and then down here I have their memory usage as a percentage of the system, right? Are the specific monitoring tools used often in enterprise systems? JakeSec, I use this stuff all the time in actual enterprise systems. Yeah. The pieces I'm going to be showing you, absolutely. Lezerbisca said, hey, I was learning Ansible the other day and curious how the nodes are deployed on the lab. After doing some Google, I was 8 hours in exploring Docker and just 40 minutes passed, and the videos are really fun and interesting. Nice. Yeah. Learning Ansible is a fun little tool. And I deploy systems with Ansible. In fact, one of the things I'm doing today is I've got these boxes that are already built, and then my job is to come through with OpenSCAP and get all of the all of the code written out to harden the boxes to a certain system baseline so that they can pass the STIGs, which is the government security technical implementation guidelines, right? They can pass the STIGs test for whatever. So we're going to be doing all this stuff in the labs here today, like building out stuff like this. I also have, this is my monitoring with, these are all the people that have tried to log into my server in the last few days. Actually, this is the last 6 hours here. These are, I don't know, a couple hundred, maybe almost 300 user login attempts in my system. And then I have who's logged into this is our lab environment. So if I were to jump into any of my systems here, like Red 1, if I jump into one of our lab systems and then I say echo hello stream, right? And then I exit, we should see in the next few seconds that was all being captured. Everything that happens down in our lab environment is captured, just so I can make sure people aren't doing ratchet shit, right? Like we have this stuff that's available for anybody to go in and use, but we still got to watch for abuse and stuff, because I've opened it to anybody that wants to use it. All this stuff is down in our Discord. And then, speaking of monitoring, I showed all those other things, but there's also in our lab environment, there's other ways to monitor things, but they still typically fall into those little areas. Here's our sandbox here. And this is what ran this morning. And it shows logins to the servers in the last 24 hours. It was mostly all root and wtemp. And then nobody else logged into any of the servers off of we have a tool called Apache Guacamole where you can log in right through your browser, right? And then it tells you how to access it and all that stuff. All right. Anyway, so let's get this stuff out of the way. Let's do a little bit of this. We'll start building some of this stuff out and seeing what we can kind of get running here. Let's go a little more into this, and then we'll dig into that stuff. So from a systems administrator perspective, when we start having issues for a resource, we always check the utilization. That's a 0 to 100% usage of something. Saturation is when we're waiting, queuing up in a line for something. And then errors are when errors start to occur on the system because of timeouts and other things. Does Prometheus eat disk space without end for anyone else? Run amucker. So Prometheus automatically, depending on what type of, it starts at 15 days, and then you can set it up. Like I've had it 31 days in one of my big high performance compute clusters. But it should automatically prune its older data out. But for me, I keep 31 days worth of data for my environment. That takes for 1,211 nodes. That takes for 31 days. It's at just over 750 gigs, but it rolls on that, so it's about 750 gigs at any time right now. So yeah, Prometheus should stop eating disk space when it gets all of the collections, and then it starts pruning older data out. If for some reason yours isn't, maybe you changed it to just keep stuff for wherever. Prometheus does have a compression algorithm to it. But and what it does is, for anybody that's when we talk about these, we have like a sampling rate, and we're sampling every 10 seconds in Prometheus, so it keeps that. But then over time, further out, it will take that sample rate and it'll take like every 5 minutes and compress them together. So your older data is actually an aggregate, and you lose granularity of your data, what we call resolution, being able to look down into things. But Prometheus can do that. Run amucker. You can configure that in there. So, okay. Startup me. Hello. How's it going? We're just going through and getting ready to start doing labs because it's Lab Sunday, right? But definitions is utilization is resource busy time, saturation is queue length, and then errors are reported in logs. Should be easy to spot. Everything is easier if you're actively monitoring your system. So that's my thoughts on it. That should be my quote, but it's true. It goes back to what Edwards Deming said and what Peter Drucker said. Like, if you can't measure it, you can't improve it, and if you can't measure it, you can't manage it. So those are two very similar quotes from kind of famous guys in this space. Okay, so why do we use time series databases, right? Like, when we get into this, InfluxDB is the time series database we'll be using, and so is Prometheus. So are so many other ones that are out there as tooling. These are two that I know and I use often. I use them professionally. I have built them for large organizations into their monitoring. RRD tool is an old one that we used to use RRD tool for Cacti. Cacti is a project that only has like four developers still working on it, but it's a really effective monitoring tool for stuff. So yeah, RRD tool and Cacti work together, I know. But yeah, so time series database, we throw data into it, and there's two ways for me. Well, okay, so anyways, let's keep going on here. Right, optimized on timestamp only. We focus on things in the series of time. Time is the fire in which we burn, which actually comes from a quote by Delmore Schwartz. But, fun fact, most of you probably heard this said. Actually, who knows where this was probably said that most people heard about it? There was a famous character that said it to another famous character in a famous series. And in fact, it was the first of the movies of that series. And this is a very famous quote as they were getting into big star battles. So, if you guys want to figure that out, you can. Reads focus on blocks of time and measurements only. So that's really makes them very efficient for what they're trying to look up. Does anybody know why most people know this quote? Time is the fire in which we burn. Data types, we can have single measurement records, so we can have the host or whatever. You don't need to have a host, but that's most of the time we'll throw in who the host is, whatever metrics we're using, and then the timestamp, and then the measure value. Multi-measure records can have the host and the metrics, whatever field we want to be in, the timestamp, and then multiple measure values, right? And we can just throw data in there, just stuff data in there. One thing about it, you're good at support. Startup, I don't know if that's 100% true. Startup said, not sure if you agree, but a common saying, when you're good at support sysadmin, it's very hard to move to another position because of the feeling we cannot lose him. He is too critical, while devs make 2 to 3 times more. Startup, I can tell you, if that happens, right, if that did happen, I would tell you, make sure that you are looking, right? Like, make sure that you, because a company can't keep you, right? They can't shackle you up in the basement and make you work in their server room, so you could leave somewhere. I have not seen, like I've seen all the Glassdoor and Levels FY, this and this. I've seen all these things where, people profess to be making whatever, but I've run into very few software engineers that make, let me make sure I'm saying this right, more than me in general, but also more than me, like, for a 2 or 3 times. I've seen the 2 and 3 times claims, but like that's 1 or 2 like principles at like one of the alphabets or something like that. That's not the average, because if you go look, so you see these levels.fyi and guys are making 400, 500K, but then you go and say, well, what's the average software dev making at that company? And it's like 80 or 90. And you're like, well, these don't jive unless it's only like one dude that's a extreme outlier on some kind of distribution chart, So, no, when you're Visa sponsored, yeah, I've worked with a lot of guys who are locked in because of their sponsors and stuff. Yeah. So that could be a problem startup. Yeah, if there's a cultural thing, or if you're, I know a lot of times people will come over from other countries. Not to single one out, but India is a very common one. They feed a lot of engineers into the U.S., and I've worked with a lot of those engineers over the years who are here on certain visas because they can work probably a little easier because now you can be remote, but still you're sponsored because of the fact that you're working for an American company, and that is a hard thing to break, I imagine. So I don't know anything about that besides working with the guys, so I'll just tell you I can focus on the engineering part and make that easier for some of you guys, I guess. But let me focus. Let me tell you guys this. The reason I put this drawing of, these are cherry blossoms, and they are falling into a little river of whatever type. This is like a little canal, right? But my point in showing this is, like, this is how I think of this type of monitoring. Time series database, getting metrics out of a system, is time is the fire in which we burn, right? Time is a flow. It's always moving forward. From right here, wait a few seconds. There were 5 seconds of time, and events happened in there that could just be thrown from these servers, as they were, down into it, and they would land wherever they land, and then they would move along in the time stream, right? This is how I think of time series databases right here. And this has been super useful for me when I'm trying to query things out of time series databases and stuff, all right? However, this is just kind of the natural flow of data out of your systems, and when we're using Telegraph and all these things, you can also pre-populate data into a time series database. So some time series databases will let you write like 3 weeks into the future. If you wanted to do predictive analysis, you can use time series databases for predictive analysis. I don't know if any of you have ever thought of that, but you could generate data based on your past data and then do a few different runs of that data to see what some outcomes are. So you could use Grafana for that kind of stuff if you wanted to. I don't necessarily do that, but also you could use Grafana to graph older things out of a time series database, where maybe you go to Kaggle. I'm always telling you guys about Kaggle and how Kaggle's got some really good data on it, and maybe you get all the data, all the crime data from like 1987 to now in Los Angeles. That's like there's a data set that's something like that. And what if you go just get that and then you populate it and you use the right time record for that time? So now you've populated a time series database all the way back to the 80s, and then you use that to graph. You can actually graph stuff like that, and you can do it. I mean, you can do it in all kinds of other tools, but Grafana is an effective way to do it out of whatever type of time series database you want to. So, okay. And then people are showing up over on the YouTube side. Hey guys, we're working through monitoring, right? We're talking a little bit about why we monitor and how we monitor before we get into the other stuff. All right, so that's our time series database. And then this is Dutch. So if you're trying to figure out who Dutch is, I kept mentioning this guy Dutch. If it bleeds, we can kill it. If it bleeds data, we can monitor it, right? Yeah, I made that. Yeah, if it bleeds data, we can monitor it, right? So that's an important thing, which also is, like I was talking about earlier, if you're writing applications or you're deploying applications, make sure that you're gathering that information out of there. Timescale DB, yep, Postgres extension is really good for that. Yeah, any of these time series databases can be used. In fact, we can go look up more of them if we want to. But I'm just going to talk about this. All right, so here's my base lab diagram. This is one that we use for the professional Linux users group often. This is one that I use in the home lab. My home lab one has a couple other links because my Grafana actually pulls things out of AWS for me. But Grafana is the endpoint here. At the far right, Grafana is like the catcher just waiting to protect home base. Like everybody's throwing data everywhere, and Grafana is going to present it up. Over here, you've got some server. This is like Joe anybody. This is any server in my environment. And I can have these different agents. Now, I have been a proponent over the years as a longtime systems administrator and systems engineer. I try to have the least amount of least amount of agents or extra processes running on my Linux boxes as possible. Now, that being said, the weight of needing good monitoring outweighs the little 1 or 2% of processing and memory overhead that like a node exporter or a PromTail would take. So I would absolutely tell you, if you're like me and I always want my boxes running as lean as possible with nothing in the back and just they're drag racers. They need to be as light as possible. But I need these things on them, right? And I don't need all of them. I can do just Telegraph and PromTail agent, and I could do just node exporter and just PromTail. It depends on what your organization's doing. But these are the options we're going to have for this lab. We're going to have Telegraph to feed metrics data over to InfluxDB, and we'll use DB2, so we're using the newer version of their InfluxDB, not the older one. We'll use Loki, and Loki will be gathering data, so data will be pushed from the PromTail agent into Loki. Telegraph will be pushing data every 10 seconds into InfluxDB, and if the InfluxDB2 server is down, Telegraph can batch those up for like 30 minutes. So they can actually batch up the metrics and send them all at once later with the proper timestamps on them, so that's important. Node exporter will be squeezing up metrics about our server that we want to track, and we can use other exporters. There's a bunch of other exporters out there, guys. And Prometheus will come along and pull, that's P-O-L-L, every 10 seconds the data out of there. But I just want you to emphasize, remember I said this one, if this goes down or this link goes down, for 30 minutes this can be just gathering data until it comes back. In this case, if Prometheus goes to do polling and the network is down or whatever happens, node exporter's down or Prometheus goes down for 30 minutes, that data is lost forever. You would just have an empty time block there. And the reason is because node exporter is just squeezing it up and waiting. It's just presenting it. So there's there's no way for you to get that data back. It's gone forever. So these are the kinds of things that you think about as you build this stuff. And this actually brings up that point what I was talking about earlier, where Telegraph to InfluxDB, this was over a disparate WAN link. Is my code shit? Bro, it's so complex. This is a lot of simple things that look complex over time. This right here. We're going to break down all the pieces of this today. So this looks complex to start, but it is not complex in the net. When you look at it in the balance of it all, this is not that complex. Just please believe that. It looks like that at first, but over time you'll be like, well, shit, this Scott's doing something simple here. He's doing something simple here. And over here, all he did for these dashboards was he stole stuff off the internet. Yeah, you're definitely here in the middle. Code. I'm just going to call you code because I don't want to say that every time. Plus, my closed captioning won't pick up the word shit anyways. So, all right, so there's our base lab diagram we're going to be doing. All right. So the lab setup we're going to be using Killer Coda. I got a bunch of labs out there. We're going to use this webhook, but it's not actually this webhook. This is a shorter version of it. And then we've got a direct connection into my ProLug systems, but this has been updated as well. So there's another way to get in there off of the Discord. You guys can go look that up in the Sandbox channel if you want. All right. So here's our first lab. Our first lab will be telemetry architecture, and we're going to do Telegraph. We're going to set up Telegraph to pull CPU and memory data and push it over to InfluxDB. InfluxDB will then sit there with the data. It'll sit in the time series database forever. Well, as long as the retention is, which is as long as that thing has disk space, by the way. And then Grafana will come along and query it. So we're going to build all these pieces right here. So, again, these presentations are up in the Discord if anybody needs them. And let's go look at, so now we'll go look at the lab pieces real quick. So they are here and here. Where's my lab? Boom. Move this back over here. That was our connection in there. Okay. So I'm going to go over to Killer Coda, and this first one, I'm going to pull this a little bigger for a second here. We'll go look through this. And it says, here's our purpose. This lab guide is to make you think as we go through the monitoring deep dive. So this is the start of this code. So if you wanted to get into this, these are down in the Discord on the projects tab or the projects section. This is a lab guide to make you think about going through the monitoring deep dive. Take screenshots of the lab and answer these questions to provide a journal or notes of actions you've completed. So I've told you guys, when I do labs, I'll just blow through the labs real quick. But this will give you the ability as you go through these labs over here on Killer Coda to, oh, shoot, that's what I'm doing. And that's, oh, I understand that, like what he was just mentioning and this and this. You can add questions as they come up, and any aha moments you have, you're like, oh, shoot, that's how that works. Okay. Because, again, I know I've been saying time series database and time flowing, and that doesn't maybe click with you yet. But over time, this may make sense to some of you. All right. So this is not prescriptive or exhaustive list of what you may want to write down. What I did was just give you the things that I thought through as I was building these labs out, okay? So you can clean this up and use it as proof to an employer that you understand monitoring of systems architecture to deep level. So I've told you guys this before. If you've got nothing on your resume, you could at least put, I completed this lab. And I even tell you guys, you can go here and strip this all off. You don't have to say you did it from ProLug. You'd say you made this shit up yourself. I don't care. And somebody might see this one day, but probably not. There's not that many people watching. But my point is, you can clean this up and show, hey guys, I went through these labs and I understand these things. Ask me questions about it. And somebody's going to be like, this guy definitely knows some things, and hope you'll figure it out. 10 times program. Sorry, I've used Nagios once, and it was easy configuring some heartbeat URLs for my web apps in the Nagios admin interface. Yeah, Nagios is still kicking, by the way. There's certs for Nagios. And fun fact, I actually have Nagios running in my home lab here. So we did a Ranger check. Let's see. There's Ranger. My wife must have fixed Ranger Cam, because Ranger Cam was pointed at the wall for the party last night. There's Ranger. He's hanging out downstairs. He is looking tired, but that's a Ranger check for people that do Ranger checks. That is also, by the way, this is a pass-through of a iframe through Grafana on an older version of Grafana, and then I have Nagios monitoring at the bottom, you guys might notice. So I do have Nagios in my environment, even though I don't really do much with it. I don't include it in all this because it's kind of its own beast, and Nagios is, I want to say it's less common. Like, we used to use it like 10, 15 years ago pretty often, but I don't really see it being deployed as much because Nagios does everything. And in my mind nowadays, it's you almost get a little bit more. If we go here, by building individual tooling and being able to modularly fix or deploy or redo new things. Yeah, Nagios is still kicking since 25 years ago. That's true. What's the new? There's a new version of it though. There's a fork that everybody uses now, and every time I hear it, I'm like, oh yeah, that sounds interesting. I've heard of that. And then they're like, oh yeah, it's just basically Nagios retooled, and I'm like, oh yeah, that is what that is. What is that? I forget what it's called. But anyways, let's go back here. I'll get you guys back on track for doing this as a lab if you want. So here's our lab, right? And then here's my initial questions. What are the 3 things we monitor? Does anybody remember? Checkmark's one of them, run amucker, but there's another one. It's called like, I can't remember what it's called. I can't remember. There's Ranger Cam. Let's go back over here. All right. What are the Isinga? That's exactly it. Isinga. Yeah. Isinga is a direct fork of Nagios. And under the hood, it's all the same things. And I've shown you guys presentations I've done on building Nagios out for companies over the years and stuff. So I have those for people that want to see them, that kind of stuff. So what are the 3 things we monitor? Does anybody remember this? It is, we monitor telemetry or metrics, right? So it's data about systems, measurable numerical data. We monitor logs, right? We want logs, logging out of the system. Logging should always be thrown out of an enterprise system in real time. Why is that? Well, because somebody can't cover their tracks by deleting logs if logs are being sent off in real time. Right? They can't do that. It's already sent off. The fact that you compromised the system was already recorded before anything else happened. Okay, so there's that. And then what's the last one? That's trace data. Trace data is how the application, how the flow of data is actually going from the different parts of the application, right? So those are the 3 things we monitor. How would you define them? Kind of like I just said. Telemetry is data at a distance. It's numerical data about the state of the system. It's utilization of the system and saturation if we're hitting 100%. And then logging is all the errors that come from timeouts and events that are happening that are always immutable. Logs should be immutable. How else would I define trace data? Is again data flowing through the system. And then where are they used in the systems world? We monitor everything. We monitor everything because if something breaks, we need to see what was the last thing that wrote out to a log. What is the last thing that worked? All right. These are questions for you guys to answer if you wanted to do this. This is the project guide here, right? Okay. Why do we use time series database or time stream databases? It should be time series. I don't know why I wrote time series databases. Why do we do that? Because they're optimized on time and they can be read on time and on metrics. So we can see metrics over time, and it allows us to do descriptive analysis, and it allows us to see what actually happened in a system over time. What are they optimized on? Always time. And then who's Dutch? Who remembers who Dutch is? It's very important. Arnold in the movie Predator, right? All right. Lab on telemetry. So look, this is what I want you to think about when we do the lab right now. We're about to do the lab, but this is going to move over here to the side. It's going to be out of the way. And we're going to do the lab on telemetry first, which is Telegraph. So we'll start with Telegraph in our system. But here's what I want you guys to think about and either be able to write out or draw out or whatever. And it's where does the data start and how is it collected? Where is the data being aggregated? So where are we holding the data and aggregating it based on time or whatever? And then how are we visualizing the data? These are 3 things to think about and to answer as we do this lab. Is that fair? All right. And I'll do 15 more minutes and then we'll take a break. I think RRD tool is still being used. Yeah. RRD tool is still part of Cacti. RRD tool is underneath Cacti. So Cacti versus PRTG server monitoring, Cacti. So yeah, it's an RRD tool based graphing solution. So there are only a few guys that are still. Ganglia was huge back in the day for us in the because I work in supercomputing, high performance compute space. Ganglia was huge back then. But yeah, if you guys have never seen Cacti, it's down to its last few developers, but it is still kicking and it is still valid. Guys, at the end of the day, it's all about being able to visualize what you want to see. I told you guys this before, and I know some of you guys haven't been around for all the streams and stuff, and I get that, so I'm going to say this again. When we go in here and we look at this little sandbox thing, This is like the simplest little thing. I've shown you guys this before. This just checks my lab servers every morning. And what does it do? It tells me if any of them aren't up. It tells me if any of them have been logged into by people. That's it. And if I come in every morning and this is clean, then I know all my servers are up. If I come in and like half of them are down, I'm like, I got to fix something. And me and some of the other guys that have monitored and built out and managed systems over the years, like this seems super simple. And you might go like, Scott, that's almost so simple it's dumb. And I go, yeah, you know what? But I just used this exact same idea in a big high performance compute system that I work on that has like 1,200 and something nodes. And we had like 80 down at any given time. And now we're down to under 20 at any given time. So that's like, we've gotten like 6% of our processing back of nodes that were just down, but nobody was looking at them. There was no light being shined into the corners of the room to know if the corners of the room were clean or not. There were parts of this cluster that were just always going to be down because nobody knew. So we shone light on it, we show light, and then we go and we fix all the things. Monitoring can come in a lot of different forms, guys. It doesn't have to be any one way. Morrison said, do you think there are a majority of organizations out there are actively monitoring their systems in-house or contracting it out to another organization? I'd say most people are doing it in-house. Most of them. Morrison. When I used to do this for companies, and I still do this for companies, I just do this as a systems engineer. I would put some of these things up on the walls on like 65-inch monitors, and then in the network operations center, people would just have. I use a tool right here. This is like the simplest little thing. I used to build this out for people, and they'd go, "That's it," and I'm like, "Yep." We'd go here, and I would just turn this on right here. This is a little thing called revolver tabs inside of Chrome. And every 10 seconds, this will just revolve through. And now on a 65-inch screen on the wall, I would revolve through all of the key performance indicators of their system or whatever. And they'd look at it and go, that's it? And I'm like, that's it. Everything you need. Companies using it for Datadog and paying enormous. A lot of companies do Datadog, New Relic. There's a lot of people paying a lot of money for this. By the way, if you wanted to start building these out, so look, this is going to rotate through every 10 seconds while I'm up here talking. I'm not touching my system right now. It's just rolling through. We can see what's going on. See if there's a lot of failed users at any given time or whatever. But if you guys wanted, and I'm not a salesperson for anybody. I'm just telling you tools that I believe in. I'm using Grafana in 2 different instances in my home environment, right? This is my home lab environment, Grafana. Did you guys know, let me show you this, in case you didn't know, Grafana has an always free stack. And GrafanaCon's coming up too. But hold on. They have an always free tier right here. Look at this. Grafana Cloud free tier. I've had this for a few years, and I don't really use it for much, but I have some stuff out there. You get 10,000 Prometheus metrics, 50 gigs of log traces and gig data for free. It's actually free. They never charge you for it. So I will link this to you guys that want that. And you could, my point is, you could build this up and you could use this as an example to show companies or whatever. It's HD running on port 22. I don't know what that question was. Okay, so let's keep going here. So Grafana, and then you can do Grafana Cloud and all that stuff like that. But you could use that to like show people if you wanted to. Zugod, how's it going? It's good for me. I'm just doing Linux stuff, right? Doing some monitoring and stuff. Getting you guys thinking about doing some of the systems work. By the way, I turned off revolver tabs. So I'm going to come over here. We're going to pull up the lab for today. And this lab, I will drop on the Twitch side, or sorry, on the YouTube side there. And I will pin it on the Twitch side. I'll just leave it for the 20 minutes. It can just be pinned for the normal time, right? So boom, there we go. And let's start this lab, and let's see if we can't get all this stuff working. So your team is determined they need to monitor telemetry in your environment. You know that Grafana can do that as a visualization tool, so you plan to deploy it on the server as a daemon. So over here, if we go back to my presentation here, for just today, for just this part of the lab, we're going to use Telegraph, and Grafana will be the endpoint. Grafana is always going to be the endpoint in our lab, guys. InfluxDB 2, and then Telegraph, and we're going to feed the data over, and then we're going to do some other stuff to feed data over as well, if we wanted to. All right, so let me get this back up here, boom, and then where's this other part? There we go. Have I ever tried a smaller organization request where you set up a cloud service for services cloud to limit their costs for setting up a NOC? Morrison, I haven't been tasked with any of that stuff, but I mean, I feel like I could do that pretty easily. I mean, in the AWS side of things, I know they're monitoring well, and I've built stuff up there for our lab, which is, for all intents and purposes, about the same size as a smaller company's stuff might be. So, and I know what to track because I do that stuff professionally. So I think I could do that. And also, like, a lot of this cloud service stuff isn't super expensive to get the base monitoring stuff set up. So it would actually save companies a lot of money over going to some of these more expensive things. The one limitation a lot of times is it's a lot more hands-on to update and to roll to new versions and that kind of stuff, make sure it's all still working. But the initial setup of it wouldn't be super expensive. In fact, a lot of this stuff I'm showing today, you could just take and go do that for a company. If somebody wanted to take this stuff and turn this into like I'm going to go to a company and deploy all these and all that kind of stuff, it wouldn't hurt my feelings any, you know. I'm trying to show you guys how to do this stuff. All right. Excuse me. So there's Grafana docs if you want to go read a little bit about it. Yeah, it depends if you want to own the stack and maintain it. Yeah, I'd probably, if I were doing that, I'd probably have like a subscription service. And typically when I did contract work back in the day, because I used to run my own company doing this stuff, what I would do is I would have people pay me. It's almost like a retainer. Like I'd get X amount. This was in the earlier 2000s when I used to do this. But they would pay me for, 2 hours a month, whether they used me or not. And then I had multiple companies that were paying me for 2 to like, and you can even make it more nowadays, but maybe even like 5 hours a month. And then if they used my time, then it just went against that 5 hours. But if they didn't use my time, it was like a retainer fee just to have me available. And I liked that. It worked as a good model. I always had money coming in. It was a good way to do those things. But I'll leave that to you guys to figure out. Let's start out with a couple of dependencies. So we're just installing some applications that need to be there for this to work. And then the next part is we're going to download the Grafana keyring, the GPG key, and we're going to put it in our GPG key in our keyrings. So our system will use it and trust that key from apt.grafana.com GPG key. Idea if there's something like a universal monitoring agent that you can install on hosts and be used by multiple software. Mr. Extremely, so the techniques I'm going to show you guys today could be used anywhere. The most universal agent I know of is Telegraph. Telegraph works to just gather a bunch of data. And when we get to the Telegraph part, which is coming up here, I will show you guys all the inputs. There are literally hundreds of things that Telegraph can gather about a system. Yeah. And it works on Windows, Linux. Yeah, that's most of it. So, yeah, FluentBit also works pretty well, especially in the Prometheus space. And I haven't played with Grafana Alloy, but I might have to start up in my game a little bit here. So let's take this. Let's build a repository on our system to trust Grafana if whatever we download comes from that keyring. That's what these steps right here are all doing, right? Which is outside the scope of this, but I'm just explaining it to you guys because that's what you're doing in the lab. Remember I told you guys in my labs you can just hit the button as fast as you want and it'll do it. But we also want to understand what we're doing a little bit because, well, we might be doing this professionally one day. So now we're going to install Grafana Enterprise. And again, where does the data start? How is it collected? How are we visualizing it? The system is starting over in Telegraph, but we're not to that build part yet. We're actually still just on the getting Grafana up. I've never set up a Google Cloud VPC, Saigama. Plus, I think that's a different terminology because we call them VPCs in AWS, but I don't know what Google calls them. I don't know. I imagine it's pretty simple. I don't do anything with Google Cloud, guys. I have AWS certs and Azure certs, but I've never even stood up an instance in Google Cloud. Morrison, this stuff is, there are 3 labs in the book that deal with this, but this is a deep dive on those 3 labs right here. So this is like hours and hours right here of us going on just 3 of the labs. Yeah. So the book covers these 3 labs, but it doesn't deep dive like this. This is like us looking at the pieces and stuff. AWS, I think VPC is super simple to set up, Saigama. You just hit the button, it'll deploy them for you. And then you can pick, if you really want to, you can be granular on your IP addresses and stuff. But, all right. let's reload it and start the daemon. So we'll start it. It's running. And if you come down here and hit this button, you'll see that Grafana's running, but it is not yet listening. It takes Grafana like 10 to 15 seconds on these systems, probably because they're a little bit smaller systems. We're going to give it just a little bit of time, and we're going to hit the button here. And it's still not up yet, so we'll give it a little more time. It's not quite listening yet. See, our listening ports are not there yet. So we'll give it another second. There we go. Now we're listening for Grafana. Now, all of you are going to have a different link here. So if you clicked on the link and went in this lab, you've got your own personal link here. And you're going to click on this, and it's going to drop you into that instance of Grafana you just built. So if you're doing this lab, which is a free lab up on Killer Coda, now you're in a Grafana instance you just built. It's admin to get in. And then, oh, God, I hate that this always wants to help. And we're going to do a super secret password of 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Boom. So now we're in the system. No, we don't want to do that. Now we've got Grafana running on our system. And it says right here the default user is password. User and password are admin. Feel free to look around the web UI and continue the next part of lab. So, okay, so we got Grafana up. We don't have any data flowing over there yet, but we've got Grafana up. Collect data from machines in your cloud node. Yeah, Saigama, yes. We're going to gather data from the nodes out here, yeah. There's 2 nodes. There's control plane and node 01 in this environment, and we're about to start gathering data, yes. Yep. Although, in this one, I think we only gather it from the 1. We can run this as a container. Yeah, Blade, you could run this as a container, sure. Yeah, you could do almost anything as a container if you want. Yeah. All right, your team has decided that the data will be collected by Telegraph. So now we're jumping over to the far side and looking at Telegraph to push data. It's going to be sent for aggregation to InfluxDB version 2.7. So we're going to install InfluxDB, verify that it's running, and then set up the organization, everything that we need. So we're going to install the same things that we did earlier. We're downloading the key and making a new repository and trusting it. Then we're going to say, go ahead and update and install InfluxDB2 on this system. We're not doing anything special. We're just making InfluxDB2. It's going to listen by default on port 8086. So 8086, right? I don't know what that is. 8086. So we're going to start it and enable it so it comes up on next boot. Not that we're going to reboot these. And then we're going to go listen and see that the listeners are open. So we are running InfluxDB. So we've got that piece built. Come down here, and you can now connect to, if you've done this properly, you can connect to that in your system here. So here's my InfluxDB coming up right here. This will run for me. Brand new instance of it. Hit this, and I've got to set some things up. So it tells me over here to set it up with, I can right-click and open this image in a new tab. And I can see that I'm going to call it user, and then some password and lab and test. So let's say user, and then password is just going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I know, super secure. And then the organization name will be lab, and the bucket will be test. So lab and test. You can do that. You can change that to whatever you want. Continue. And now it says we're ready to go. Okay, boom. Never. I'm going to copy this key right here, and I'm going to go throw it in Notepad++. So Notepad++ has that now. I'm just going to save that over there. And I'm also going to say, well, I don't need the other things because they're already saved. As far as all right. So we're in our thing. So let's just say quick start. Boom. And now we're into this system. It's going to give us a whole bunch of stuff that we can do. A whole bunch of configurations and setups and all kinds of things. Let's come back here to the lab. We've got that part going. And Street Track said this is your new favorite YouTube channel. Nice. Well, the goal here is to get you guys doing this stuff professionally. So in your research, you find out that Telegraph can write out to InfluxDB2. Okay, good. So we're going to get Telegraph set up, and we're going to install Telegraph, set it up to push data into InfluxDB2, and then we're going to verify that the data are flowing through everywhere, right? Set the solution. We have to reset this up. We don't actually have to reset up the Influx repo. It's already there. But we'll install Telegraph. And once we have Telegraph up, we've got to go fix a few pieces. There's 4 pieces to this that we need to fix. Actually, not 4. There's There's 5 places we have to fix. But I'll show you them here real quick. So get this. Telegraph will be up. Telegraph is actually turned on by default. So if I go look at my system, as soon as this comes up here, I'm going to say systemctl status, telegraph, right? And there is telegraph. Telegraph's dead. Systemctl start telegraph. And, whoops, system, start telegraph. Let's see if it starts. Let's see. So there's something stopping it. Let's go see. Why is it not starting? Journal. Gotta make this a little bigger. Why isn't Telegraph starting? Give it the old restart. Okay. So Telegraph is not starting in our system, and that is not good. That's not a good thing to start. This website, like leak code, is it freely available? Kiss Killer. The thing that we're doing is a free lab up in Killer Coda. Yes, it's also pinned right there. You can go in it. It's free. Yep, very free. Okay, so why is this not? Oh, motherfucker. Why does it keep? I'm not sure why. I wonder if it's very strange to me that it wouldn't start by default for Telegraph. It's like something's definitely changed on the install side. Let's see. Failed to start Telegraph. Not giving us anything useful there. We just see that it's dying. See how it's getting started. Nothing in there. Okay. Let's go see. Why is this being ridiculous? Let's take everything $$ here off. Let's see if we can start it with just the config. Let's see if we can start it with without all that other stuff, because I've never even seen all those other things on there. It's like things got added later or something. I don't know. Let's see. Nope. If you change a config file, you gotta redo a daemon reload. Oh, motherfucker. If I could spell any time today. Oh, still doing it. Oh, mother effer. Cannot type today. Okay. So let's see if the failure is because there are no outputs found. So maybe we can just go configure this and then restart it. Let's just see. Maybe that's what it is. So this may be something new for Telegraph. So we'll just go into Telegraph. Let's just fix it so we'll have an output, because it says right here, error running agent, no outputs found. Well, we don't have an output configured yet, but we're going to set one up. So let's do that real quick. So I'm going to do / for InfluxDB. So InfluxDB. And right here, I'm on InfluxDB 2. I've got to fix five things on this configuration. I need to have outputs to InfluxDB version 2. I need to have URLs uncommented, so both of these need to be uncommented. I need to have a token. I need to have an organization, and I need to have a bucket. Now the token is right here. I'm going to hit I right there. I'm going to come over here. I'm going to grab my token from earlier. Remember I told you guys to keep that token somewhere. I come in here, Control-Shift-V, I'll paste it. My organization, I know from right here, this image, it was lab and test. That's what we used, was lab and test. So I'm going to say lab, and the bucket was test, escape, :WQ, right? And then let's see if we can restart that. Super annoying. So Telegraph, that's a new behavior for Telegraph, guys. I've never seen that run like that before. Telegraph would not start if it does not have an output to load. I didn't know that. That's well, let me say I didn't know that. That wasn't an old behavior. You used to just be able to start Telegraph. Now you actually have to configure apparently a working output for it to work. So if you guys can see right there, it's got the loaded output for the InfluxDB version 2. So we've got Telegraph sending data now. InfluxDB version 2 is sitting there hopefully collecting the data. And then on the far side, we should see on the Grafana, we should be able to read it and see the data passing all the way through. So if we wanted to, out of overabundance of caution, we could come here and we can go look at buckets. And now we've got a test bucket. Before we just had monitoring and tasks. That's all we had. Now we've got this test bucket. And we can go into this test bucket and start seeing data that is coming out of these different servers. So I've got CPU, disk IO, kernel, all this other stuff. All right, so we got that. We're going to go to Grafana now, and let's reach back from Grafana. We're going to go to connections. Actually, let's do it in the lab. Once this gets set up, we'll see that Telegraph's running, and we've got the right outputs. So we'll go to our last page of the lab. It says you've set up all the pieces. You now have to create a dashboard in Grafana to verify that everything's working end to end. So we're going to set it up to have a data source for InfluxDB2. There's the link. And here's all the setting it up. If it's working, we'll see 3 buckets found. We'll actually see it connect to all of that information. So let's go and do that real quick. So we'll go over to our Grafana. Get rid of this for now. We'll go to our Grafana. We're going to add a new connection, and then I can just go right here and say Influx. Here's our InfluxDB. And we're going to add a new data source. And then it's InfluxDB. The query language is going to be Flux, because that's going to be for the version 2. All right. Then down here, we're going to use localhost. It's going to be the same thing. You use localhost or 127.0.0.1, right? If you have any authentication or any of your zero trust stuff running, you could put that here. Come down here. The organization was test, and the bucket, the organization was lab, and the test was the bucket, right? And then the token was that same token that we had from earlier. So now I should hit save and test. Oops. Hold on. I probably used I probably had the wrong thing in my paste buffer. Hold on. Let's grab this. Copy. Boom. Paste it. Save and test. Data source working. 3 buckets found. So Grafana now is ready to see any of the pieces here, right? The Grafana is ready to go start building dashboards for this. If we're back here, we've now set up Telegraph to feed data into InfluxDB2. We saw that data in there. And then now Grafana is going to be ready to query it over from there. So we're gonna go grab that. All right, let's go here. Let's go over here, and then so we'll create a dashboard. Actually, before we create dashboards, there's different ways we can create dashboards. We can have a new dashboard, new folder, or we can import a dashboard. So the problem with the dashboards here, and I think I have it here where I don't really show you a dashboard, is there are dashboards out there that have been created already. Right? There's like hundreds of them, maybe even thousands of them. but this one doesn't really have a lot of them already built for it. So we would probably have to build our own dashboard for this. So I'm going to show you guys how we build these dashboards. Where's Influx getting data from a VM? Yeah, Saigama, this is a VM that we're in here. Yeah. So look, real quick architecture. We're on control plane. We only built this on control plane. We have ss-ntu ntulp grep-i for Grafana. Grafana's running here, right? We have Telegraph running, and that's pushing the data over. Oh, no, Telegraph's pushing data, so it doesn't really have an open port. And then Influx is the port. So Grafana's on port 3000. That's what we're hitting to connect here. See the 3000 right there? InfluxDB is 8086 right there. And then Telegraph is pushing the data over there. Yeah, Telegraph sending the data. All right. Okay. So we've got all those things. We can check this, and the lab is done. But now we want to go build the pieces of it, because this is where the fun starts to happen. So this is where, kind of, if you were to pull up the lab here, the lab book, where you've answered these questions, you understand how the flow is going. Then I have these pieces of data where I populated these in the lab for you, but you could start to go and build these yourself if you wanted to, right? So let's look at how we would build these, because these things are pretty useful. We got CPU usage, disk usage, memory usage. For the system, we can have high watermarks for how much CPU or data, disk usage, and other things. So I added all of this stuff. And then this is our last question about this lab as we start to build this. How do you see yourself applying this data to what you know of the IT industry? So if you're in the IT industry, guys, and you're doing this, what would you want to see coming out of your system? All right, so let's go over here real quick. We're in the InfluxDB instance right here. And let's say I wanted to see the CPU, and I wanted to see the usage of the whole system, the user, and we don't want the idle. We want the system, the user, and maybe we want the idle, right? All the other stuff, not really super useful. And we'll do it for all the CPUs on the control plane node, because that's the only one we're gathering data for right now. And if I hit submit here, this will start to build a cool little dashboard for me. But InfluxDB isn't really optimized to show stuff to other people, because I've even asked in these labs before when we've worked on them, I say, well, why don't I just stop here and give you a link and you can come in and read your data out of here and everybody's cool. This isn't really designed right here to show other people. This is kind of like being down in the, you know, people say like, don't show, you know, don't air your dirty laundry or whatever. This is like down in the laundry room. Why would you want to go to the laundry room? You want to just get the, you know, you want the sheets just put on the bed if you go to a hotel or something. You don't want to go down the laundry room and get them yourself. That's what this is. This is all the back end stuff. So I want to show you guys, this is how you build this out if you've never done this before. You come here and you just hit submit and you built this, but you built it by taking all the pieces you wanted, right? Then you click here on script editor and it'll show you what that query looks like. And you'll learn these queries over time. But remember I said that all time series databases are optimized on time? That's what they are. They're a flow of time. This is just looking within whatever time range start and stop that you want. But we're going to just grab all this right here, hit Control-C, move over to our dashboard for Grafana, say I want a new dashboard, add a new visualization. I'm going to use the data source InfluxDB, and I'm going to drop that down right there. All I did was copy it from here to here. And if I hit right here, I'll just apply it. There's the start of my data. And this is the last 6 hours. I can change this to only be the last 30 minutes. And doesn't that start to look like exactly what we just saw? Now inside of Grafana, we want to do some other things too. But this is like, what do you want to call this? This is like, this is just sprucing it up. This is like finishing work. The other stuff we're doing is like roughing it in, making it all work from start to finish. Where did I generate the query? I'm in the Influx over here. So in the InfluxDB, you start in a query builder like this, right, Mr. Extremely? You build this query out however you want. So I start on the left and I just kept clicking buttons. And then you've got a script editor right here, right above me there. There's a little script editor button. And it will take this query that's running right here and it'll flip it and turn it into the script. So this is the query. Then you grab it, Control-C, go back to your query builder, and then or you know, whatever your next one is. And then come back over here to edit the panel, and then you drop it in here. The data source, if you have multiple data sources, like in my lab, my Grafana has multiple data sources that it can go and pull from. This is just the InfluxDB one. So think about this. What if I had InfluxDB and Prometheus running? Grafana can be an aggregation endpoint for all of them. Because when I make a new one of these, after I apply this, I can come right here. Where is it at? I can just say add a new one. Let's just add a new visualization. And I need to go get the data for my visualization. So I come back over here and I go, that was all cool. But what if I said I want my memory? I want memory. I need to see how much memory we're using, right? And then maybe I go down with memory. And over here, I want to get rid of all these. What's my next memory piece? It says CPU total and control plane. Let's see what this looks like. That's not going to give me the results I want. So I'll click all this off, get rid of it all. This is, again, just when you're first learning how to do this. Hey, SM, how's it going? Control plane's my localhost Saigama. Yeah, if you jump into these labs with us, you'll have a control plane of your own. Yep. Let's go back over here. Let's go to, whoops, get out of here. Let's uncheck that. Where is that not unchecking? Let's go to, let's watch processes. This will be fun. Let's look at how many processes we have, total threads in our system for control plane. That might be valuable. And then maybe we want to know how many zombies. If zombies are over there, that's no good. And then maybe I want to know how many are running, how many are idle, and maybe how many there are total, right? And I'll just hit submit on this, and it'll give me some scale here. And up here I see total threads are 608, so I could keep a total running count of how many threads are on this system. And then I can maybe keep track of, let's see, total threads. The total number of processes are here. And then how many idle and how many running and how many are zombies. So maybe I get rid of the total threads, right? And then maybe I take all of these other things, because all of these other things, all of these should add up to be what the top one is. So you've got, in the system, you've got 209 total. You've got 166 sleeping, 43 idle, and then all the other ones are down here at nothing. And maybe you're just there. Yeah, Saigama, that's cool. I mean, yeah, I try to be at least an effective teacher. I don't have to be a great one, but I try to be effective. Let's say I grabbed all this. Script editor, grab all this, boom. Come back over here to my Grafana for my new panel, drop it in. Call this my number of threads and status, right? Something like that, right? And then you can have a descriptive. There's another thing here. I could say, you know what? 200 is what I expect. I never really want to see that over like 500. So maybe I set like the top, a soft max of like 500, because maybe that's a scale that I like to see. And I think that looks pretty good. So now I got number of threads and status. And then maybe that comes over here to the right? You can just grab these pieces. I never named this one, but this one is CPU usage for, user and system, right? That's and aggregate CPU usage as well, right? And since this is always adding up to 100, my soft max for this is 100. So now it's going to scale that out. So CPU usage of the system is based on 100. These should add up to approximately 100. John XAF said, "How good are you at security?" I mean, I could security my way out of a bucket, I guess. I've been doing security my whole career, I guess, if that's what you're asking. So if I want to add another VM, do I need to create a new data source, correct? Saigama, no. So, no. The data source, so let me come over here real quick. If you had, here's my little pen, right? Let me pull up my little pen here. No. The architecture is set. This is one of the reasons this is so effective for me as an engineer, is now this is some server right here, and we set up Telegraph, check. We set up InfluxDB, and we set up Grafana, these parts right here, right? So now if you had server 1 to N, right? And N is a common way of saying however many servers you had. You could just set them up with Telegraph and point Telegraph to InfluxDB, and it would catch it as long as it had space. And this Grafana monitoring over here could be reading from all of those. You do not need to set up another endpoint. This part is done forever, and this part is done forever. All you need to do is add servers to this. That's it. In fact, in my home lab and then also professionally, when I deploy these things, I build these, and then I just deploy these with Ansible. Super easy to deploy a bunch of nodes and just point those configurations back. Yeah. And these are ready. InfluxDB is ready to catch. Grafana is ready to read. So all those pieces are built. It's done. We've set up all the pieces we need for all the data to flow the way we need it to. So let's go back to our lab real quick. We only have, by the way, when you do this, you only have 30 or 60 minutes in the lab, right? So you only have so much time. In fact, over here it says we got 30 minutes left on this lab, right? So we're over here. We could keep building these out. I'll go back to Query Builder and I'll say, okay, let's get rid of these. I don't want memory anymore. We said earlier we wanted disk space, right? So I want the maybe used percentage of my system for my VDA1 because that's my root disk. So multiple VMs can flow data into Influx. Yeah, Gamma. Yeah, I flow thousands of them into InfluxDB. Absolutely, yes. And then I don't need to go. You don't need to go all the way down if you don't want. You could stop right here. And here's my disk space. But that looks like a whole lot right there. Used percentage, that looks like a whole lot right there. But watch what happens here. This is an interesting thing. That looks like, oh shoot, Scott just shot to the roof. He used all the data up. All the data are gone. But look at the scale of this. It's 49 to 49.57. So it's 49.56 to 49.57. That looks really bad. But watch this real quick. Let's grab this script editor. Let's grab all this. We need all this tasty data, right? Come over here. We're going to build a new, whoops, cancel. What's that? Build a new, add a new visualization. And we're going to say over here, we'll call this disk usage. Disk usage, right? Come down here, drop our stuff in there. And then before we apply it, though, we're going to come down here. And if disk usage is a percentage, the soft start will always be 0, and the soft max will always be 100. And when I apply that, that doesn't look nearly as scary for disk usage right there. If the server which pushes logs is compromised, can it go and affect the Influx data storage if the attacker finds the token for pushing data? Yeah, of course, Whisper. Yeah, if things get compromised, yeah, absolutely. People then have access to the next piece. Sure. Yeah. If they knew to look at the processes and then went and found that token, absolutely. That would be a problem. Yeah, you gotta, there's different levels of risk for all kinds of things. Remember, this isn't log data yet. We're not doing any log data yet, guys. This is just telemetry. But let me show you guys this. This will be fun. So this is tracking. This is going to refresh every 5 seconds over here. So now every 5 seconds it's going to query. And I'm going to go over here and I'm going to write. So I'm going to say dd in file equals dev 0. So we're just going to write a bunch of zeros. Out file is going to be root and then big file. Block size will be 1024K. Count will be 4,000. So that'll be a 4 gig file. And yeah, that's it. So I'm gonna take that. If anybody wants it, I'll link it to you guys here. So if anybody's doing this with me, there's the thing. I'm gonna hit that real quick. Right? So that's gonna write a big file. And then let's go over here and let's just watch this. Let's just watch it for a second. I'm gonna drink some water. You guys see I'm not using my hands here, right? I just made a 4 gig file out there. I expect disk usage to shoot up right now. My hands are not on the keyboard. I'm not cheating here. The system really is monitoring. Also, look, that it took some CPU time to do that as well. So we saw a little CPU system going. Number of threads didn't really move much. We saw it move a little, but disk usage is now leveled off. That's what 4 gigs looks like on the system right here, based on where it was at. So now we're monitoring disk, we're monitoring CPU, we're monitoring number of threads. It's pretty good, pretty all right. And this is an example dashboard. This is like super simple. But then you grab what you do if you're doing this lab here, right? If you're doing this as a lab with me, you go and you grab your little thing here, and you grab some of these little things. You make, like, look, I've done different stuff here. Like there was disk usage, there was CPU usage, there was memory usage. You can add that into your thing and make it your own so that you have something for a portfolio. If you have nothing else to show that you understand systems work, as you build these labs out, grab the screenshots. Throw them in that thing. Again, strip the stuff off the front. I don't care if you give me credit. Strip the stuff off the front and say, this is my lab monitoring of Linux systems. And as you do these labs and figure this out, now you've got cool little visualizations, and people be like, oh man, you could build that for our systems, and we'd be able to track like if any of our disk usage was high. Over the last few years, we've had some crashes where disk usage got high and nobody was watching it. You go, I happen to know how to fix that. Here we go. Right? This is systems engineering, guys. This is monitoring. We're in the monitoring portion of it, but this is what we do. This is the cool project side of stuff. But maybe somebody's already got monitoring set up, and now it's your job to build new monitors, right? You could build, if you had access to some of the stuff, you could go build new monitors. And again, remember, look, this looks really bad. That looks like oh God, I just lost everything. But you got to remember the scale of a graph by default can be really messy. Look, 49.56 to 49.57. Oh gosh, we've crushed the server. But then you realize that's not even at 50%. And this visualization looks a lot better because we set a hard zero, well, soft actually, of 0 and 100 because it's a percentage, right? Percentage of usage, right? Yeah, Grafana does have built-in alerting capabilities. Yeah, Whisper, some of the stuff that we did when we first built this lab setup out, we had some stuff where we showed how to do that. Now, I'm going to show some stuff that gets a little more complex, but I hope that this is valuable. So that's the dashboard. But what if you wanted to, what if over here you wanted to send data in there and you wanted to do it through, you wanted to do it through over here. So we can go to sources, and you wanted to use like Python. Python's an example that I know pretty well. Now they show you right here. This is a walkthrough of exactly how to do this. Oh, I need to install the InfluxDB client. All right. Control-Shift-V, pip install InfluxDB client, right? And that'll be there. Boom, whatever. And now if I do Python, right, and I go import InfluxDB client, it should import it with no errors, right? When you import it, you got to do, hold on. Boom. They give you a token here, so you can export the token in there. I can also use my other token. But InfluxDB underscore client. Did I do that wrong? It's unfixed. Yeah, that was my bad. Underscore client. Sorry, guys. All right. Boom. Now I've imported it. If you're a systems guy like me, sometimes you're called on to give... in some environments, people just use virtual environments, which they probably should. But sometimes in production systems, you're asked to add packages. And if you're ever installing something for the guys that are using Python, that's a thing. This is a little trick for us systems guys. Again, I'm not a programmer, guys. That's not what I do. But I can run Python and make sure that I can import whatever package I'm about to tell my developers I installed for them. Does that make sense? This right here this is like going out and starting the truck. Then I know it's started. I know it's pulled in whatever package I need. Okay. So, by the way, guys, for if anybody got lost, I'm just over here in the Telegraph, or in the InfluxDB, rather, and I'm in sources, so now it's telling me how to set up a client. So I can do all this right here. Here's this. Here's my URL. So I can just make a file real quick. And I'm going to exit 0, right, to get out. VI, Python... right, I don't know. Doesn't matter. .py doesn't matter. Control-Shift-V, and I'm gonna change the URL here to the one that's actually correct. They gathered the one that they thought we needed, but I'm gonna go $, and it's going to be 127.0.0.1:8086, and close that off. So that's the client. And then we're going to write in the lab, and here's our token. We need to put in our token here. I can use the token that I had from earlier. I don't actually have to use the newer token, because this token this is a root token, so it can read anything. And if I do this, escape:\wq, and then I do Python write, that should run, and there were no errors. So that's actually good. We didn't do anything with it yet, guys, but we now have built from over here, by basically the virtue of copy and pasting, we imported InfluxDB client. We have OS and time by default. we have InfluxDB client, and now we've made sure that we could write. We didn't do any writing yet, but we made sure that all these pieces worked. Because, you know, again, if the system exits 0, that's pretty good. So I'm going to go next. And it says that I can write into a bucket test that I have a bunch of measurements. So I'm going to write a bunch of measurements into the system. So I'm going to do this real quick. I'm going to come back over here. VI my Python. Shift G to go to the bottom. O to get a new line. And I'm going to write this out. Now, I don't see any errors in here. It's going to wait 1 second before it does each of these writes. But escape : WQ, and we should be able to write this. And it gave us an error on line. Where's our error? Where's my error at? Bucket test. Bucket. Bucket needs to be, it's test up there, but I just like to put it in here because sometimes, I don't know, I don't always trust. Let's see. Name client is not defined. Oh, they have this thing. So right here, it's write client is equal to InfluxDB, write API. I think that we can do. Oh, they have an error in their stuff. Right, that's right, client like that. They got an error. They got error in their stuff. Nope. Hold on. Right client. That is right. No, that was right. It's I've had to fix this before, but I don't remember where. Bucket test, org lab, URL. I have the, hold on, I have this somewhere. I actually have the version of this down in our Prolog projects because we've had this before where I did, oh, client equals that and then write API client. Is that, hold on. There's always an error in this. Ah, there it is, client. Maybe there's a problem here. Hold on, let me grab, I'll just grab this because I fixed this before and I don't remember exactly. We can this is actually working because I know that this works. This is my same one. I'm just gonna just melt everything. This is the one that I wrote before. The only things I need to fix here are the token then, right? So $, and then my token will be right here. And then this will write, so this will write in. I don't even remember what the difference is, guys. I just know that that'll work. So this will write, and it's going to write every 1 second, so it's going to take a little bit of time. But now we're going to copy that over to read. So watch this. Wait, did I set that to be? So copy Python write over to Python read.py, right? And then we'll VI our Python read. And what we're going to do is we're going to read the values. That's the next thing they're going to make us do. So they're going to say, well, if you could write it, you could also query and read all of that, right? So the query read part will be right here. And we're in the read one. So now come here and it's fine. Right, so now we're going to read it, and now we got to read it from the measurement, which was called, I think it was measurement Scott was what I had called it. Oops. God damn it. That's why I shouldn't be using up arrows so much. Measurement is measurement Scott. All right. Don't copy it again. Write it. Wait, not write again. We don't want to write again. We want to read this time. Now the read is going to go and it's going to give us all of the reads, and it's going to give us the record as JSON output. So this looks a lot, but for people that deal with data a lot, that's like, oh, that's an easy thing to go pull through. But here's the thing. The first value was 0. The second value was 1. The third value was 2. The next value was 3, 4, 5, 6, 7, 8, 9. And then I started to write 0 again because I accidentally hit the write again, right? So I did that, and I'm going to grab the Python read. And I'm going to grab all this and go throw it back in Discord so I don't forget to grab it again, right? So down here, I'll say from the presentation read. Right, so there's that. That's the how you son of a bitch. That little bot, man. It's like the bot, if you ever say my name in the server, it corrects you to Scoot instead of Scott. Fisherman guy, bro. Bane of my existence. Anyways, we're almost out of time. We only got 14 minutes left. What if I wanted to, let's go read, we want to read it in the aggregate, because maybe I need to know for the last hour what's the full, yeah, it's terrible. What's the full value? So look, guys, I'm literally going through like what they show you how to do. I'm not even doing anything new. We can change that query at the end to query this and aggregate them all up. So watch this. We're gonna copy. Fuck it, we'll write it. We're gonna copy Python read over to Python aggregate, right? Because we're gonna aggregate up the reads, right? vi Python aggregate. Come down here. We're going to we're just gonna hit D500D to just delete everything down to the bottom, and then we're gonna change this, and it's gonna query everything. But look at what it's going to do. It's going to give us the mean this time. Right? For those people that do data science, you've got the mean, the median, and the mode. We want to see the mean of all the data for the last 10 minutes. Escape :WQ. I'm going to cap that Python aggregate out real quick just so I have it. Before I do that, I'm going to run it, right? Make sure it works. So Python aggregate. And now this should read out and give me one field, and the value is 4090909. How do I know that's right? Like, I mean, I know I counted 0 through 10, and then I put another 0 on it. But let's go make like a big, let's just be like out of control here. Let's go to our write, our vi, our Python write, and we're gonna come down here and we're gonna take the time sleep off. And we're going to change this from counting up to 10 to like, I don't know, 1,000. We'll go a little over 1,000. But there's no time now. So we're going to send 1,000 API calls real quick to this system, right? Let's do that real quick. So we'll do the write, Python PyWrite. I'm going to let that run in the background. I'm going to go drop this over in the, this is the aggregate. So if anybody's doing this and you want to go into our Discord, whoops. Damn it. And you want to go on our Discord. That did all the right. Let's look at our Python aggregate real quick again. Grab this here. If you need this stuff, or if you're playing with it, right? Because this is, I mean, this is what we do here, right? These are free labs. You can go do them whatever you want. But there's the data. Escape :WQ, and then let's run that. Let's run the Python Py aggregate. And what I predict here is this number that's going to come out, this value, will be closer to like 500. Because it'll be the mean of 0 through 10, a 0, and then 0 through 1010. Which is, well, 1,010, right? It'll be somewhere in the, yeah, look, it's 499. So that's the aggregate of all those numbers put together. So we got the mean of all those numbers for the last 10 minutes. Now, if we waited a few more minutes and then we started doing that, some of those earlier numbers would fall outside of that range window, right? Because we're dealing with range in our system. All right. I know this is a lot, guys, But the reason the lab exists is for you to go and play with it. And guess what? If you're doing this lab and you get near the end here, and you see the little 10-minute timer, I'm running out of time, you do not have to pay for Killer Coda. You can literally come over here and refresh the page, go through the first parts of the lab again in probably like under 10 minutes as you get faster just pushing those buttons, and then you've got all the rest of the time here to play and build these databases out and build this information. By the way, if I come back over here and I look at my buckets, what happened here? We just had we hit 75% of our follower goal. I don't know what that means. I didn't even know I had a follower goal. That's really funny. I'm going to go to my buckets here. We'll go back into test because we're writing to our test bucket. Now I have this measurement Scott. So measurement Scott can be aggregated as a tag value, and I can go look at what the values of those are. And here's all my tiny little values of it being written every second. And the value went up the whole time. And then the value kept going up higher and higher as different data points were written. So look at all this stuff. Submit that. Go grab that. We can keep track of whatever that value is. If that value was being written all the time, if that value was, I don't know, something coming out of some application we have that just checks to make sure that I have the number of a thing that I check a lot in like big file systems. There's a file system called GPFS from IBM, and we look for waiters. We look for systems and processes that are waiting to access the file system. And if waiters ever go high, we want to know. So we track them. And this is the same kind of thing. People call the idea of what you track is in a system is a key. People will call it a KPI, a key performance indicator. Sometimes users get tracked. I'm very glad I haven't been in like sales or anything like that for 20 plus years. But when I was younger, I remember like, and I hear people talk about like key performance indicators, and I'm just like, man, I wouldn't like being tracked like that. For me, the key performance indicator for me is if all my systems are up, right? That's the main thing about engineering. I tell people I've been late to work for the last 20 years because engineers are never late. We arrive exactly when we intend to, but we're like wizards like that. But the point is, you have to figure out how to track things and make sure that your systems are running the way that you expect. So, okay. I am going to take a break. So, keep working on this lab if you want. All the extra data of what we're doing, that fucking bot, are down in Prolog projects. All the stuff that we're doing here, and when we originally did it, people put some really good questions and stuff in here, so you can see. Look, we originally did this back in 2023, over a year ago. We originally did this presentation, and we were just grabbing pieces. But here's all the stuff, all the pieces you need if you want to go through in the presentation that I'm doing right now and all that stuff. And this was, here's other things. This is when we're going to write out to Loki here in a little bit. There's the Loki write, so if you wanted to work ahead, you could. You just need to change. Actually, there's nothing to change on this one. And yeah, this one works perfectly. Yep. All right, so there's that. I'm going to take a quick break, but I will put up this again so you guys have it. Right? Move this over here. We're going to see my time run out eventually on that lab. It's got 6 minutes left. But here was your lab on telemetry. How is the data flowing? Where does the data start? How was it collected? All these kind of things. I'll turn this on so you guys have, it'll link through these. Let me get rid of that. Let me get rid of that. Let me go back on this one. I'll go give Ranger a treat. Ranger looks like he needs a treat. So we'll leave it on Ranger cam. And I will pop off of here. Whoops. And I will pull up my hourglass. And I will say hourglass. And we'll take a quick break here. And let's see. Hourglass. Say work on lab. Work on lab and check on Ranger dog. I'm on a break. So I'm going to take a quick break. You guys are welcome to hang out. Zalax said, hello, come across your channel on YouTube. Watch the first video, Socratic Method. It's helpful, and we'll continue the rest. Hey, Zalax, we also have a Discord, so you're welcome to hang out in our Discord. Let me pull that up for you guys. So on the Twitch side, there's the Discord, and on the YouTube side, there's the Discord. Feel my lo-fi said, do I use Grafana? Yeah, this is going to be all Grafana monitoring lo-fi. So here's what we'll do. I'm going to take a break real quick. We'll take an 8-minute break here. Feel free to go grab stuff. I'm going to go give Ranger a treat and go hang out. Anybody that's still working on the lab, work on the lab. And I'll be back and we'll get back to it, okay? That sound fair? One of you, let's see. Runamucker's in charge. He's in charge, so I get back. How's Ranger doing down there? Run amucker, you can't be gifting stuff when I'm gone. But I do appreciate that. Alright, you guys see Ranger down there? Look at him. What you guys can't see is I have little quail in my backyard. They are running around eating grass and bugs and whatever quail eat. So, oh man, another gifted. I appreciate that. Make sure you guys refresh your browser so you don't get a whole bunch of ads and stuff. You won't get ads for a while if you have a subscription. For you guys that don't know how that works. YouTube side shouldn't be showing ads because YouTube's a bunch of chuckleheads. YouTube should not be showing ads on my channel. But who knows? Maybe they are. We'll see. I don't really care all that much. But all right, let's long story there, but YouTube's basically a fucking retarded organization. I know, I'm not supposed to say it. Oh, it won't even say the word. No, whatever. Whatever. I don't care. Can't work their stuff out, give you a set of steps, and then their steps don't work. It's ridiculous. Well, their steps work exactly like they're intended to, but they break your shit. And then you're like, well, all right, well, I guess I'm not fucking doing YouTube for a while. I'll still stream out there, but I don't really. They can all go kick rocks for all I care. Anyways, so happy Sunday. Looking for our HC exam. Anyone have any tips? Street Rack. We have some people doing, that have passed our HCSA down on our Discord. Docker and Ansible. I can tell you RHCSA doesn't have a whole lot of either of those. The RHCE is all Ansible, though. I know that for sure. But I haven't done ever any of the Linux certs. I've always just worked in Linux. I have certs in other parts of the industry. But yeah, I can't tell you much about RHCSA. I know that some of the guys down on our Discord can in our certification channel. We got quite a few RHCSAs and RHCEs hanging out. All right, so my break's almost over. Ranger's break's almost over, which means he's just going to go back to laying around. But let's do the next part of the lab. I think anybody that hung out with us and did that lab would probably find that you were able to get rid of that. You will probably find that you were able to build all of these pieces, right? And so this is what we just did, all the telemetry architecture, right? We did write checkpoints of data out. We did read of those data points and then aggregate reads of those data as well. So there you go. All right. Lab on telemetry. While we were doing that, we sped up the system. We did some other things than a stress command, but there's some other things that we could have done in that lab if we wanted to. Okay. So we come down a little bit. Now we're going to do the logs one. Now we're going to write out, we're going to do audit log and syslog, and we're going to feed those over into Loki. So Loki is going to be built as an API endpoint for us. And we can push anything we want into that API endpoint. We can secure that endpoint with certificates if we want to, but we don't, strictly speaking, need to do that kind of stuff. We are going to push the logs over to Loki for the audit log and the syslog. And then I've got this other part that I'm going to show you guys where we're going to write logs directly from our little application, whatever our application does. I don't know. Right, I'm not an app guy. I told you guys I've never been a professional coder, but I've supported a lot of them over the years, and I know that they write things out to log files. Well, we could have them write things to log files and then use the PromTail agent to push that to Loki, or we could enable our our dev teams and our engineers. When we talk about DevOps, I'm typically on the operations side, keeping everything running and building the servers and stuff, and then the developers lay their code over the top. Well, we can enable them to push to our Loki endpoint, and then we can give them the ability to see what's going on in their system. So let's work on building this type of log architecture out, right? So we'll build this top part here in the lab, and then we'll add that other piece that I just described, okay? So here's the thing. Once we complete the lab, go to the answers directory and execute the Python to write Loki. Yeah, actually, I added that in, so that's actually in the system now. Okay, so let's do the lab on Loki here. So give me a second here. I'm going to click on... Actually, I don't even need to click on it. I know where it is. Oops, not that one. Pull up my other lab real quick here. Ranger Cam, Labs, Loki. So here's our monitoring one. here it is over on the YouTube side, and then on the Twitch side, I'll just drop it for, I'll pin it for, and I'll make it 40 minutes, I guess, because we're going to be talking as we do it for a bit. Okay. I'm going to pull up the chat over here. Again, you could have this up, and you could be answering these questions. But here's the next part. So this is the lab on logs. Where does the data start, and how is it collected? It's important to think about. Where is the data being aggregated at? So the Loki endpoint. And then how are we visualizing the data? And how might we want to look at the data? Robodom, you're hanging out on YouTube? Nice. Well, Robodom, you're in charge over on YouTube, so you can do any of that stuff you need. And I can drop the Discord one more time on the Twitch side, and I can drop it over on the YouTube side as well. But I always like when Robodom's around. He's one of my mods. He kind of keeps things going. Let me drink real quick. But I want you to think, as we do anything in any type of monitoring, where's the data start? What methods are we using to gather the data? Where's the data going? And then where are we pulling that data and visualizing it with? This is like the crux of everything that you do, right? And this all feeds back to that original idea of, if you can't describe everything you do as a process, you don't know what you're doing, right? Like, we want to know. Isn't it good for us to use a distro, a virtual machine, instead of Killer Coda? So Zalix9, I'll talk about that for a second. So he asks, isn't it good to use a distro of a virtual machine instead of Killer Coda? Guys, I don't care what you use to practice this stuff. Let me just tell you my journey as an educator, right? As a guy who's taught college at the post-secondary level, you know, and for 15 years I've been teaching college, and I've been engineering a long time. The hardest thing, if I wanted 41 people and 24 people between Twitch and YouTube, if I wanted all of you to have the same system, that is the hardest thing to do as an educator. I would spend 6 hours, 7, 8 hours getting all of you in the same environment, and nobody would be able to do it. So the reason I use Killer Coda, the reason I like Killer Coda so much is I don't have to spend time getting you guys all building systems, right? Like, and people are like, well, I wanted to use Ubuntu and I wanted to use Red Hat, and then now we're back at this. So we're just all in the same system, and then we're focusing only on the piece. It's the same thing I tell people, like people will be like, oh, I don't know why you're using straps when you shrug, like in the gym. And you're like, I use straps because my hands can't hold the weight that my shoulders can, so I strap. And they're like, oh, I would never use straps. I would just make my hands stronger. And you go, okay, well, do you not use a rack for squat? And they're like, what do you mean? You're like, well, don't you put the weight up and then squat from a rack where you get underneath it and then you squat? Like, because I can squat over 600 pounds. So if I have to pick that up from the floor, I'm effed, because that's a lot of weight to pick up off the floor. But I can put it in a rack and I can squat it. So you see what I'm saying? This is my point, guys. Like, use the tool for exactly what you need. So I know you're not saying that, Zalix, but what I'm telling you guys is I try to get you guys focused on just the thing that matters and not the things that don't matter. And people argue about, like, if you should wear gloves in the gym. And it's like, who fucking cares? Like, get your weight up, right? Like, that's the goal. The same thing here. Let's work on what we care about. So yeah, if you want to build your own stuff and then do these same labs, it would work. But it's just that I don't make you guys do that, because we would just spend an all day getting you guys into labs. So, all right, let's do the lab. It's here. You guys have it over there. All right, so your team has determined that they need to offload and monitor Linux logs in your environment. We could just stop there and talk about the fact that Linux logs, any logs of any system, need to be thrown off the system in real time. And you say, why would you want that, or why is that so important? It's so important because if the server goes down, the last thing the server did was logging, you may be able to determine what happened to that server before it went down. However, if you have to wait until you get the server back up and there's a hardware component failure or something like that, you may have to wait days and days to figure out what happened to that server. That's not acceptable in an organization. You need to have information, like, readily available. So that data needs to go. If that server went down because it was compromised, you do not want to be bringing it back up in your environment. Or if the server was compromised and then, got turned off after the compromise or something, the person did what they wanted, pivoted, did some command and control in your system, we don't want to turn that back on and reintroduce that. So Logging allows us to see everything that happened in the system, even while the system is still down. So this is huge. Get the weight up. Yeah. So you know that Grafana can do that as a visualization tool. So we're going to use Grafana to start. We're going to use Loki to tie into it, right? Yeah, so where's the data flow? We know how this goes. And then we're going to talk about how do you see yourself applying this for what you know in the IT industry? And then what is the query language used in this lab? So we'll look at that here in a little bit, okay? So the solution to the lab is just going to be to install the things we need for Grafana. Some of you might look at this and go, isn't this the same as the other lab? Yeah, every time we install Grafana, it's going to look the same. So let's install our dependencies. We'll go down and we'll get the GPG key from the Grafana site, and we'll put it into our keyring. Then we'll set up a repository that's signed by that key, so we trust things that meet that keys, that have been signed by that key. That's what we're doing here. And then if we download Grafana Enterprise and everything works, we should get a running version of Grafana on our system, right? Just like we did in the first lab. Pretty straightforward. I mean, it makes installs a lot easier than they used to be, right? All right. So I'm going to watch that run. Then we're going to start Grafana. Make sure it's enabled on future starts. We don't really care that much because we're not going to be rebooting these boxes. Let's get that going. Okay. Now, we see Grafana running, but when we check the status, we do not see it listening yet. This is important, guys. Grafana doesn't start right away again. It takes about 10 to 15 seconds on the first startup for Grafana to start listening. That is probably something you will never run into in your career, but I just want you to know that, like, if you ever check Grafana and you're like, oh, shoot, Grafana's down. I just started it. It says it's up and running, but it's not listening. It's probably because in the time we just spent there talking, we now have Grafana listening on our system. So Grafana's up, guys. Grafana's up. This is the same exact part of the lab from earlier. In fact, when I built the labs, it's just a copy. This is an exact copy from the other labs, right? So I hit check. And now it says your team has decided that the log aggregator will be a tool called Loki. Loki just sits there as an API endpoint and just accepts data in and allows data to be read out through LogQL. LogQL is a very common logging query language, right? By the way, that's an answer over here. What's the query language you use? LogQL, right? Okay, so let's get Loki running, and Loki's going to listen on 3100. So we're going to come down here. We're going to make a directory for opt Loki. Opt is a very common place in Linux systems to put agents and other things that aren't normal software. App software will a lot of times be an opt. Sometimes people will make an app directory. It depends on the organization. But opt is a very common place. So if you're new to Linux or you're new in an environment and you're looking for where people have put stuff, check in opt. That's where third-party tools tend to be. Okay, so we're going to cd into Loki. So we'll go into the directory. And we're going to download a version of Loki that should be running for this environment. And I believe I fixed this. Last time I had done this, we might need to fix out or comment these two lines out. So let's go fix that real quick. I added this to lab. So vi Loki local config. And there's two lines that for some reason they just don't work in this lab. They're right here. And I'm just going to go ahead and comment them out. Just like that. I hit I, put two comments, escape :WQ. Or you can just go in there and hit DD and it'll delete them, right? I mean, you can. I'm not going to tell you how to use your VI. There's other resources for that. If you do tell me that, what does opt stand for? I don't even know what it stands for in the big scheme of things. I just know that it's. Now I don't know. Yeah, I don't know. I don't know where the opt standard comes from. I just know that that's a place that we tend to put stuff. So Abden asked, like, what's the opt stand for? I don't know. That's lost to the history before my time. It's probably an old Unix question, but somebody may know. I just don't know. I just know that's where a lot of times we'll put agents and software on systems. I know that it tends to mean third-party directory to most of us. So, yeah, but what they picked opt for, I don't know. Probably options. That's what people are guessing. Yeah, SGN. I'm just gonna call you Signal. Said options. Yeah, I think options probably pretty close to right or what it is. Okay, so let's copy over our Loki service file. So I've got this Loki service file, And if you've never messed with a Loki file, let's go look real quick. Here's our config of Loki. This is our local config. And this is going to have that one part commented out because we don't need it. But I'm going to show you guys something. I really don't like this right here. They have at the bottom here, by default, Loki will send anonymous but uniquely identifiable information and configuration. And then down here they said, if you would like to disable this, uncomment the following lines. So what I'm showing you guys here, the reason I want you to read this and understand this is because I actually don't like that they did this. By default, when you put a pound sign in front of something in a Linux configuration, and then you say reporting _ enabled is false, what do most of you that have been in systems world, is anybody here that's been in systems world, what do you think when you see that? I'm going to tell you what I think here in a second, and what probably most of you are going to say too. This means something. When something's commented out, and then reporting _ enabled is false, by default, to me, that means that is the default in the system, right? That's what that means. When something's commented like that in a config file of any type, you're seeing the default configuration if you don't change it. But that's not what's happening here. They say if you would like to disable, we're going to turn it on for you, and here's the way to turn it off, but you've got to uncomment this to make that the default. And that to me is like bad poker right there. That's shady business if you ask me. Most people are going to want to turn that off in an organization because most people don't send stuff like that. Most people don't want to send that data out of their clusters and that kind of stuff. That's not that it's a security problem. It's just, hey, thank you for your open source, but we're not going to contribute this level of production stuff back. And that's up to you. But I'm going to tell you, your security team does not want that on. So I want to call that out. I think that's bad pool or bad poker or whatever the hell that term is. Don't do that. Okay. But anyway, so let's go look at our service file. Our service file is one that is super easy. It's just etc systemd system loki.service, and it just starts Loki with that config file we just had. That's it. That's all it does. So let's restart. We need to do a daemon reload. We already did that. So let's enable and start the Loki service with one command. So can we start it with one command? Yes. And then let's go see, is it listening on port 3100? Yes, it is. So now we've built Grafana and we've built Loki. Oh, by the way, when I did Grafana earlier, I didn't do it. At Grafana, I didn't go to the bottom. I didn't reset. I always reset this. Let's reset our Grafana to the... I don't like leaving that instance open too long. Like I always change it. So admin. And then we're going to change... That's terrible. And we're going to make a new password. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Right? Terrible passwords, but they work for now. Now we're in Grafana. So we got Grafana up, and we've got Loki up. And so those things are ready. And I said, your team has decided the log aggregator will be a tool called... Okay, we did Loki part. In research, you found that PromTail tool can push logs over. So PromTail can push over to Loki in real time. Your task will be deploy and configure PromTail to push into the Loki server. So we're going to install PromTail. We're going to make it push the varlog offlog and varlog syslog off the server into the Loki aggregator. So we're going to push those two logs. And then we're going to make sure PromTail's running. So come over here. We're going to make a directory for PromTail. We're going to cd into that directory. We're going to download the most recent version of PromTail, or the version for the lab. And we're going to unzip it. So then we're going to have the file. So if I ls in here, I'll see the zip and the executable file. But then I'm going to copy in the configuration file that I want. So I copied in the configuration file that I made. You can get a default config file, but I had to change this because the default one is varlog messages and varlog secure. Most of you that do Red Hat or CentOS or Fedora or Rocky or Alma, and back in the day CentOS, right? You know that varlog messages is your syslog, and varlog secure is where everything else goes. Well, Ubuntu is a little different. So we had to change to varlog syslog instead of varlog messages, and we needed to do varlog offlog instead of varlog secure, which those are the common ones for the Red Hat style of Linux. But ours is a little different. So the scrape configs are, where is PromTail gonna look to grab data to send off to our Loki API? So So here's our Loki API. This could be anywhere else in our organization that we want to send clients. And if we had multiple URLs, this is just a YAML file. You guys see this is YAML, right? I could send this to multiple clients. So I could have multiple clients down here that are just my Loki API version 1 push. So just push data in there. This can be set up more. If Loki is locked down with certificates, I can have this use certs to only be able to write to the Loki endpoints that it should. Probably in some instances, that may be a security consideration for zero trust. On the Loki side, I can set certificates so that only things that have the right permissions can write into my Loki, so that somebody couldn't just fill up this endpoint. Because, by the way, with an open API endpoint like this, that's the first thing that you could do is, well, if I can't control it, nobody can have it, and we just fill it up with data, right? That's a way to break something in an environment, right? So the first type of denial of service. If I can't have it, nobody can have it, right? Anyway, so we come down here, we go to fill it up, and we're going to copy in. So now we got the service file, and the service file is super simple. Just runs against that config that we made. Daemon reload, start the service, verify the service is running. The service is running, and I see that it's got a process ID to it, so good. So we have all the pieces now. Let's go over here, so we'll hit check. And you've set up all the pieces. Now we've got to create a dashboard in Grafana and verify that everything's working end to end. So can we push those log files over in and do that? Now we're going to import a dashboard in this one. This one's a little different than other labs because we've got a dashboard that somebody made out there in the world already for us. So we're going to go to our Grafana. We're going to set up the Loki data source. Then we're going to import the dashboard. So I'm going to go to Grafana. I'm going to say that I would like to create a new connection. And the data source is going to be Loki, right? Add a new data source. We're going to say 3100, 127.0.0.1, because it's local. And then I don't have any authentication or any special TLS settings, right? Transport layer security, well, like I was talking about with certificates. We could make certs and we can put them in there, but that's not really necessary for this. Nothing special here. One of my favorite things about Grafana, I'm going to show you guys, this is one of my favorite things about all of Grafana right here. When I hit save test right here, it's going to show me, you're good, bro. I connected to it, and I know that there's something there. And I love that about Grafana, is it always tells you, hey, Fohammer, how's it going? Hopefully you're having a good Sunday. We're doing labs. We're building stuff. I'm showing people how they could build out a little, you know, if you don't have anything in your resume, if you're new to the industry and you want to put something on your resume, this is as good a place as any to start. Hey, I know how to monitor systems. You know, I know how to build out some of this stuff and gather this stuff. So check it out now. I did that, save and test. So now that's all built. I can come back over here and I can say, all right, I want to go to my dashboards. And I'm going to import a dashboard. I don't want a new dashboard. I don't want to make one. I'm going to import it. And I'm going to drop in this version. Whoops. What was that? What was the one? 1369, right? Yeah, 1369 right here. I'm going to load that up. And it's going to say, hey, that's a logs and app one. And folder can be dashboards. And then the Loki data source that it expects. Excuse me. I'm going to hit there. Boom. Now, I have auth and syslog. Those are my two major ones. So I'm going to hit auth. I'm going to leave it on auth here. And I'm going to go over here and I'm going to make it refresh every 10 seconds. So how might I check? So auth-log has a couple of things. I can see sudo attempts. I can see failures. I can see all kinds of stuff. Let's go do some things over there. So I'm going to move this over here for a second. Move this over here. Let's do a few things to our system here. And let's see if they pop up over there. So I'm going to let's just user add Scott user. So user add Scott user. That made a user. By the way, is making a user a security action? Is that going to go in auth log? Oh, shoot. Look at that. Scott user. Did I spell my name? Oh, Jesus Christ. I spelled my name wrong. All right. Scott user. Right? Spelled my name wrong. Oh, fuck. Oh, my God. All right. Long morning of labs, right? So we got user. And by the way, there's my two users over there. Now, let's sudo up substitute user to Scott user. And then, I didn't make a home directory, so that's a problem. And then I'm going to say sudo -i. I'm going to try to become root. and I tried to become root, and then I tried to let's say sudo su dash. Can I become root? Oh no, look at this. Look, I'm getting errors over here. Scott's not in sudoers file. And Scott's failing a bunch of authentication failures here. Oh no, Scott's about to get in trouble. 3 incorrect password attempts, right? Look at all these. I'm getting all these errors over here. Yeah, Scott's trying to privilege escalate. But I've told you guys this before. There's 2 reasons typically that sudo will happen. You'll have sudo attempts where somebody's trying to escalate to privileges that they shouldn't have, right? Which is what I just did. My Scott user shouldn't have any root permissions. I didn't give them to him. But there's also valid reasons, like sometimes your developers will get a script from a vendor and they'll just try to run the script and they'll fantastically break all over the place because it assumed that they had root in like a dev environment or something. So then your devs will come to you with their hat in their hands and they'll look like one of those little what are they called, like pangolins or whatever, those little things that are always going like this with their hands, and they'll like look like they're about to ask you for a favor, and they'll be like, hey buddy, I need these permissions, and you go, okay, well, I can see all of the things your thing tried to do. What if I just in our dev environment gave you all of those pseudo permissions that script tried? And then, yeah, you guys know what I'm talking about. What are those little things called? Pangolins? I think they're called pangolins. Pangolin. Yeah. And they always look like they're about to ask you a favor. They're always like going like this with their hands. They're really funny little things. They always look like they're about to ask you for a favor. But they're like these little armored armadillo looking things. But anyways, all right. Serious day. Labs are all serious. So look, I've got this cool little thing over here, and I can see things happening over here. But then I also have that's okay, right? Like I've got all the logging going in here. I've got all my syslog stuff. I've got all the messages for syslog, and it's for the last 1 hour, and I can see logs and things that are happening, and that's pretty okay. That's actually pretty useful. I can see errors. I can look for errors. Right, if there were any errors, I would see only errors coming over here. That's a lot of errors. I wouldn't have expected that many. But I can see errors. I can also dig in. Looks like there's all kinds of errors coming up on the syslog stuff. Yeah, it looks like sending errors over there. But then I can dig into this and see exactly what's going on. Most of this we want to programmatically access, though. I don't want to be trying to grab this stuff and look at it with my eyes. I want to aggregate it up and then do queries against it and stuff, right? My job, I tell you guys a lot of times, my job is just to get this stuff all flowing. I just want the data flowing. I let other people go and figure out, what the data's showing them. Does grepping for not in sudoers file work? Yeah, so you could do, for not, so I could do, so I'm back to the root user, right? And I can say grep not in var log auth.log, and I might need to do a -i, and it would show me the not in there. Yeah, right. So those are those things. But the emphasis of this lab is getting stuff off the server. That's funny. In this lab, though, you might say, wait a minute, Scott, you're on the same server. I know, but this Loki box could be anywhere in my environment. I could have pointed at any IP address. So we're sending it off the server. We're pretending to send it off the server. This is a poor man's lab. This is a poor man's lab, right? We got one server in there. It's free, right? They gave us the server for free over on Killer Coda, so it's a good thing to test. But the point is, we could be anywhere. Hey, thanks for the follows, guys. I know I missed some follows, Eric and Sirs. Hopefully this stuff's useful to you guys. Lopsided Pixel, all you guys. Hopefully this stuff's kind of useful. The goal of this stuff is to get you guys into doing this stuff professionally. Same in Grafana QL. Fohammer, yeah, this is they're using LogQL for this, and we're gonna look at that a little bit. I've never tried Grafana QL. I've never messed with Grafana QL, unfortunately. But now let's do some things. Living in the UK makes it difficult to follow the time zone. Yeah, Dad and we do, all Sundays are labs. But because somebody asked me to do a deep dive on monitoring, I decided to do the deep dive again. And plus, YouTube tends to I don't know, I haven't been able to figure out the YouTube side too much, but it seems to me like people will watch stuff later if it's kind of technical. So I get a fair amount of people watching stuff and asking me questions later. So I like that, by the way. I like showing you guys how this stuff works. But remember I told you in this lab, so I'm going to pull this back over here real quick. We'll look at this here in a second. I told you guys in here, we could, how would we apply this? Well, we want to get the logs off the servers. Yeah. And Deaden, I got like, I don't know, something happened on the YouTube side. So like a lot of people have been seeing the videos. I've had like, I think like almost 160,000 views in the last like month, which is a lot for me. You know, that's good. Getting people, it's driving people down into the Discord so people can ask questions and get, you know, harassed by our little bot and all that good stuff. All right. Yeah, what is the query language used in this lab? Let's do that real quick. How well do these labs prepare you for certifications? Quan, these are not really designed for playlists or for certifications. These labs are designed to just get you into Linux systems. So into Linux systems, getting ready for systems engineering. But Quan, a lot of this stuff will not, none of my labs that I have right here are designed to get you ready, not on the Linux side or on the Ansible side. Some of my Kubernetes stuff is to help get you ready for the CKA. But no, these labs we're doing today, this would be mostly if you just wanted to like build out monitoring and build yourself a little portfolio to show somebody. You know, maybe if you wanted to do a contract job with somebody and you wanted to show them stuff you could build in these little labs and test and make yourself a nice little, kind of like here where we were showing some of the different things that we can show people. You know, you can go and build that stuff. So, okay. So we come back over here and there's this other thing then in this lab. So let me show you guys this. In the lab, we have the answers directory. And I made this file here that now you can go look at. And there's Inspector. How's it going? More Loki. Right. And this one decides to write into the logs file, and it's going to call, the job is going to be lab logging. So lab logging is not there now. Excuse me. We can say on server host, detected an error, Scott is too awesome. You can change that to your name if you want. And we're going to write this a few times in our environment and see if we can get this log right here, this logger, to write out. So let's say you were building a little Python app that did something, and you were deploying that Python app to like 30 machines, or you asked me to do it in the environment because I've got root. You could have in your little deployer or even in your app when it comes up, it could write back to, instead of writing out to a local file, a lot of people are doing like just app local files. Sure, maybe you do that. Maybe you also write out events to a little payload here that goes out to our Loki. And then, so we'll do this and we'll just pretend this is like some, you know, this is just a function and you could just pass in whatever you wanted because, you know, you guys that do Python know how to do all that stuff better than me. But you just call this and just dump it into the payload each time as you write out. So you write out to your file locally and you also send it up here. So now all 30 of your nodes are in one place, right? So let's just do this real quick. Let's just say here, we'll just do a Python Loki write.py. And it gives us a 204, which is good. Any 200 is good. It means we hit the API. We didn't get a redirect. We didn't get a client error on our side. We didn't get a 500 error. So 400 is client. 500 is server. 200 is good. That's actually pretty good. So let's come back here and look at our logs. And now, remember, we only had syslog and authlog earlier. Now, if we refresh this page, because this is just refreshing in the page, but we got to refresh the page here. Now we've got lab logging. And lab logging says on server control plane detected the error that Scott is too awesome. I agree. Scott is too awesome. And I could sit here and watch this, and over here, I could just do a little while loop, while true, do, Loki, write, Python. It's not executable, so we're not running as a script, we're running it out of Python. Loki, write.py, sleep 2, done. Boom. So now it's going to run every 2 seconds. Come over here. It's going to run over here too. Every 10 seconds it's rolling here, so it's getting all those. And there's our error. But if this was coming in from multiple nodes, we would be seeing it from each individual node. We would know if certain nodes hadn't showed up. We would see if you had proper error conditions for your stuff and you were, again, writing them out. Loki would be like one stop, what we might call a heads up display, or a single pane of glass is a common term for it, where all of the systems are reporting to this one place, and we just see, maybe you only send me errors and it just looks like a clean screen, and I go, well, on my side I deployed it to 30 machines, and you go, well, over here I got no errors, and I go, it's probably good. And then you start doing whatever other checks you want. But then maybe you go to one node and you turn it off just to see, or you cause it to fail just to see an error in testing. And then later on we go, okay, well, we're good. Now we just hand this to the NOC, the Network Operations Center, and at night they just watch this and they should never see anything pop up here. But if they start seeing something pop up here, we know one of our nodes has gone down. I mean, look, guys, this stuff is like, I told you guys at the beginning, because somebody mentioned, like, this is complex. It looks complex at first, but then when you go dig into it, you're like, that's it? That's it? That's like easy. I literally think that this is no more difficult. In fact, I would maybe argue that this is easier than like the guy who's out farming that's like digging the irrigation ditches. I'm just digging my irrigation to bring the water to the things that I need to. And it's the same thing here. The data are sitting over here. Then the data are flowing over here. And then we're looking at the data. That's it. That's it. That's all of it. Nothing sneaky. Nothing up. I don't even have sleeves on. Nothing up my sleeves, guys. This is it. This is all I got. And this works on literally thousands of nodes. This kind of stuff. You might have to scale this box up. You can use a little one CPU node like this for it, but you know, point is you can do all this stuff. All right, let's go kill that. Don't need the loop anymore. Done. Boom. What is the query language used in this lab? Where would you practice with it more? Let me show you that. So we did this lab. Where would we go? Where would we go to practice it more? So we come over here. We look at this, and we say LogQL on Grafana, and this is where you would go spend more time with that. You could build that lab out real quick, and then you could do a bunch of little LogQL stuff right here. And this is fun. You could come in here, and you could go to the actual LogQL analyzer, and I wouldn't do this with like work stuff. Like I'd make sure you sanitize your data out, but you could throw any data you wanted into right here after you look through and figure out your queries. You could take any data you wanted there. So I can come over here and cat var log secure or syslog here. Let's grab all this stuff. I don't know. Boom. I come over here. I can draw again. I wouldn't do this with like sensitive data at work, but in a lab environment, do whatever you want. And then I come down here and I go, okay, I want to log, I want to look for, right? I need to figure out how to do log queries against, so it says here that I could do filter, I can look for things. So then maybe I come over here and I go, okay, well, filter is equals, and then I could look for something, but maybe I want to look here for, let's find something that's not everywhere. There's a bunch of stuff here. Let's go to, I don't know, info. And I run the query here, and that found line 1, because that had info in it. It found line 2, found line 3, and then it didn't find line 4, 5, 6, because those don't have info in them. It gave us a nod, but it goes, look, this line's been filtered out. That wouldn't show up in your query when you queried this thing for info. Now, you guys might astutely have noticed that in the lab, I just made you go grab something that somebody else had already built. The reason I did that is because I didn't want you to have to spend a lot of time with this. This is now that you're done with the lab and you've built this up, now you can go through and go, okay, how did this guy, by the way, there's your learn LogQL right there. But by the way, we can come here if we wanted to. And we could make this editable. The dashboard's currently not editable. We'll save the dashboard and whatever. Save it. And we'll close this out. And then now it's editable. So I can come here and I can edit this to see how is this guy getting that stuff. And it says sum count over time. Job is app. So app was up here, lab logging. And then it searches over whatever interval is given as one of the special variables, right? So here's this. And then string match, if I want to look at how string match is being added in there. Edit. And yeah, search is the search, which is the value of string match that it was doing, right? So there's variables. By the way, we're not getting into this a lot with this, but you can set variables up in your dashboards. So here, I can go to, when I go to edit the dashboard, I can go look at variables, and there's app, which is label search for the value job, and then there's one that's labeled as error. So label values and error, when we go look at the actual dashboard, are right here. App, well, yeah, app and string match. Those are the two variables. I don't know why that's called app there. Oh, there it is. There's the variable app. And then there's just some definition. App and search right there. And you can make them set values. You can have them be empty by default or actually set to a host or something. You can set other variables that aren't even used. I mean, you do all kinds of stuff. But in this case, I'm allowed to pick from all the variables that are there, and then I could just pick anything I wanted to look at. So I'm back to my syslog. I'm looking for error. I'll take error off, and I'll go back over to lab logging, and there's my lab logs. Which, by the way, it only found error because error was there. If I looked for Tom, I wouldn't find any data because there is no Tom. There's only Scott, right? And then if I did a capital Scott, it won't find it, I don't think, because it is case sensitive. Most things in the Linux world are case sensitive. So we go there, or we can. So if we went back, watch, check this out. If we went to here and we went to auth and we just looked for user, we would only see the user things. Or if we only looked for root, we would only see the root things. And if we only looked for sudoers, we would only see the sudoers events. And you can filter them down here by they're looking at the string match, but the string queries are all coming from being built over here. So my point in showing you guys all this is, again, our goal on the system side is to get all the data where it's available for data analytics teams, business analytics teams, all kinds of things, right? We want to look at it for historical data and descriptive analysis of what's happened, but we can feed it to other people on our teams for predictive analysis of when we're going to run out of storage, and there's all kinds of things that we can do. But you can't do anything until you have the data. Can't do anything until you have the data. All right, so that's the lab on logs. Trace data is going to be, I didn't ever build my own node exporter system for this, but we'll do regular node exporter. I never built the custom one out, but we'll go and we'll just grab information from a server and see what's going on there, and then we'll feed that over to Grafana as well. And I'll show you guys that you can also look directly at Prometheus data. Prometheus is a time series database, also has a pretty good little interface for you to look at your nodes and see what's going on with them. So we'll look at that as well. All right, what's our time at? Man, we're at 2.5 hours. I've been talking for a while. But if you're doing this lab with me, or if you're working on any of these labs, there's a lot of information here for you. So here's what we'll do. We'll pull Ranger back up. Let's get out of this one. Let's get out of here. Our next lab is going to be Prometheus and Node Exporter. I'm going to link this to you guys on the YouTube side, and I'll pin it to you guys on the Twitch side, because Twitch has all the functionality. I'll pin it for 20 or 40 minutes so you guys have it. And I will pull back up for you guys that want to do the labs with me. So now we're on lab on tracing. How is the data collected? Where does it come from? How's it being aggregated? And how are we visualizing the data? That's always the flow. And then here's some information from Prometheus that we can kind of look at. This was something that I had showed before when we did this. So let's go here. We're back to our questions. And is there like final questions here? How do you see yourself applying what we're doing now to the system, right? Yeah, this Grafana can be run locally. Yes, Alex. I run 2 Grafana instances in my home lab. Yep. This is one of my Grafana instances with Ranger. That fucking dog. And then this is another one that I have in my home lab of just tracking things. Tracking the dungeons. Has anybody else been in the dungeon since we started? No? But you guys can get in the dungeons if you're down in the Discord. You can go in. I have all those nodes available for you guys. Just have to go in the Discord and find out how to get in there. All right. So let's do this lab. Starts with Grafana. Says your team has determined they need to monitor telemetry in your environment. You know that Grafana can do that. Let's set up Grafana. You can read the Grafana docs. We can get the basic requirements that are needed. These are the dependencies, as we call them. And then we're going to install the Grafana repository the same way we did before. We'll get the key ring. We'll make we'll get the GPG key. We'll install it to the key ring and put it into the repository. So that's done. And then we'll download the latest version of Grafana. That's the thing that we're doing here. Yeah, and by the way, yeah, Zalix, this is a 1 CPU box with 2 gigs of RAM in it, and it can do it. So you can run Grafana pretty easily locally. It doesn't use much. In fact, my environment, this is my home lab environment here. If we go look at my Grafana boxes, Grafana is running, he's not using that much. Almost nothing for CPU and almost nothing for network. Look at that. That box is chilling. And then Grafana 2 for performance is the same way. And that's running monitors of 30 nodes or whatever. So it's hardly doing anything. So that's the home lab. Some of you guys have seen the home lab when we talk about it. All right. So we've got Grafana. Let's install it. We've installed it. Let's start it. When we start Grafana up and then we go and we check the status, I keep emphasizing this, it takes about 10 to 15 seconds to be listening. See, it's not listening yet. So we'll give it a second here. Give it 10, 15 seconds or so. Rerun the command. And now you'll see there it is listening. If it's listening, you'll have the link right there in your lab to go in there. This will be your instance of Grafana. And you want to change the password and username to something other than admin. admin is terrible. Shouldn't use it. So we'll do 1, 2, 3, 4, 5, 6, 7, 8. Something a little more secure. All right, we got Grafana up in our lab. So Grafana's up. If you've done any of these, if you've done all these with me, you've installed Grafana 3 times now. All right. So we go here, and the next part is we know that the team has decided that Prometheus will be exposed, data for Prometheus will be exposed via Node Exporter. Your job is to get Node Exporter up and running on your server. So install Node Exporter and verify that it's running and exposing on port 9100. All right, so we'll make a directory for opt Node Exporter. We'll CD over there. We'll download a version of Exporter, Node Exporter, and we'll copy in our service file. And then we'll go look at the service file. Service file is this simple little startup. Just call this and start it. And then we'll cat the file to make sure, yeah, that's good. We'll enable it and turn it on. And then we'll go look and we will see all of the page actually running right here. Watch. Boom. In 2 seconds, there's all of the information being pushed up as a web page. We did a curl against our local host on port 9100 against metrics. And everything is key value pair up and down the page. Anything that's not commented out is going to be read in as a key value pair that Prometheus will put into a time series database for us. So this is being exposed, but again, if you don't read it, this data is just going to sit there exposed forever. We also didn't lock this down in any way. We didn't put a certificate on it, so anybody in our environment can read these metric data, the metric data out of our system. Is that a security issue? Do we need to think about that? There's a lot of things that we can do. But for the lab, we just turn it all on. In your research, you find out that Prometheus can read the telemetry data for Node Exporter, and you also know that Prometheus is a time series database. Your task will be to deploy and configure Prometheus to poll, it's P-O-L, ask a question, telemetry data for Node Exporter. Install Prometheus, configure, set it all up. So we'll do a user add Prometheus. We'll make a directory for Prometheus. Prometheus likes to live in varlib Prometheus, And there's too many things to change for me to care about changing them, so I'm just going to let it live there. So we download it, and we put it into that directory. And then we make that that directory owned by that user, Prometheus. So we change everything back to Prometheus in that directory, even though we just downloaded it as root. We're going to make a directory for etc Prometheus and copy in our Prometheus config, which is a basic config that we have. We'll go look at our basic config, and really all we're going to do is go read 9100 from that node. Localhost 9100, we're reading that data on port 9100. There's also 9090, and that is Prometheus checking itself out to make sure that its own configuration is good, and that's fine. We'll copy in a service file and look at the service file. Service file is pretty straightforward. This is their basic one. We've got the config file that we just looked at. We've got where we're going to store the data, varlib Prometheus. You might need to store that data somewhere else if you've got some big data storage somewhere and you don't want to have it just on the local machine. Varlib Prometheus could be some high-speed storage or something. Like if I wanted to write it out to GPFS in a system or Lustre, you could do that. Performance would be, fine with that typically. And then Web Console, there's some templates that you need, and we'll go ahead and just let those exist where they existed. We could have changed this all to opt, like I had said before. I didn't want to do that, but we could make this all out of opt if we want to opt Prometheus. One of my favorite things about this to show you guys, and this is important as you build systems, anything that you run out of systemd. Systemd starts as process 1 on a modern Linux system and is owned by the root user. So the root user starts systemd as the system comes up. The kernel kicks off systemd, starts starting processes. If a process starts and there's no designation of a different user, it starts as the root user. So like when we did Telegraph in the other lab, Telegraph I don't think it had its own user, so it was actually being run by root, I'm pretty sure. Prometheus is not like that. Prometheus is just some user. So if I go over here and I do sudo -l-U for Prometheus, Prometheus isn't allowed to be sudo. It can't become root or do any sudo commands on here. So if somebody manages to compromise Prometheus on this server, they find out that Prometheus is running on port 9090, they've got a good exploit for the, they went to the CVS the CVE database from NIST, and they used Metasploit, and they found this vulnerability on my environment. For some reason it's exposed, or they're in my system, and they take over this service. However they do it, right? They use Metasploit, and they're just script kidding it up and running it against everything, and they take over this system. What did they gain by being Prometheus on that system? I mean, I guess they can read the time series. They can read the data that's being aggregated. But they didn't compromise this box and become root and then pivot over to root and have root in my environment. They didn't get that. They only got a very small part of my system, and they could be annoying, but they're not compromising the box. They have not rooted the box. But if they compromised this and this was not Prometheus, they would have just taken over the server. So if they compromise the service that's running as root, they've compromised your box. So that's a thing to think about in the systems world. And now we don't use nobody anymore. It's not a dedicated account. There's some sort of round robin quasi user account systemd uses now. I know it's not a helpful comment. No, that's fine. Aqua. I don't know if there's some other one, but I'm pretty sure anything that you would find from systemd in modern Linux is still just being run as root. But if there's some kind of quasi user account systemd round robins through, I wouldn't know about it. I haven't seen that before. That could be a thing. I haven't seen that before. Maybe that's the way like Rel 9 does it or something. I haven't played with Rel 9 too much. I'm mostly on 7 and 8 still. So, but one of these days I'll go read on the newer things. But all right, let's start this up. Start it. Running. Go check. It's running. Good. So now we can go look at Prometheus right here on our node, and there's Prometheus. There will be a problem when you go to status and look at targets. You can see when the target is up. So we're hitting that endpoint and we're getting that data. But you won't be able to go because when you click on this, it's going to try to read it as localhost, so this is going to fail. So obviously it's not going to be able to read control plane. But just suffice it to say that it is reading in the environment. Systemd to use instead of root. Oh yeah. Aqua, that'd be interesting. I'd like to see that. All right, so we get this. We hit check. The last thing to do is, now we've set up all the pieces, let's grab a dashboard. And the dashboard we'll use is 159. That's a real old dashboard. And here's our solution. Here's all our data. Here's all the pieces we need. We need to be connected to 9090. So let's go over to our Grafana. We're going to say connections. And we're looking for Prometheus. We don't need the alert manager. We need Prometheus itself. There we go. Add a new data source. Prometheus, and we can say Prometheus is on localhost 127.0.0.1, and we don't have anything special. We should just be able to save and test, and it'll tell us we've been able to read it. That's very good. That's one of my favorite things about Grafana, is it tells me you're good. So I save and test, good. And I'm going to say that I want a dashboard. I'm going to go new import, and I'm going to import that dashboard, and it's going to say that's a Prometheus dashboard. And we can select the data source, Prometheus, and hit import. So now it'll build that dashboard for us from that system. And I don't want the last hour, I want the last 15 minutes. And now I can start to see stuff about the system right here. Very nice information about the system that comes up. Now, we've got that. That's a good little start. We're gathering data. The data, there's a good amount of data available to us here. But what if I look at this for a second and then I go, well, what was I looking at there? I was going to show you guys something. Got that. We've got that. I had something I was going to show you guys here in the Prometheus. Hold on. Why am I forgetting what I was going to show you? It's over here. Prometheus, you can go look at all the stuff, the nodes up. You can see that it's being scraped. That's useful. It tells you how long the scrape took and when the last scrape was. So you'll see that across all your nodes. You'll see if any nodes are not up. That's not what I was going to show you, though. I was going to show you guys... Something I wanted to show you guys in here, but I don't see it now. By the way, here's some different information that you could pull up and look at. I took a screenshot before and I put it in the lab, so you guys could also do that if something was interesting. And then how do you see yourself applying this? What would be useful here for you? Look, these have mean, max, and minimum being shown because maybe that's something you wanted to see about the system. Maybe you want to spin the system up and see how this behaves, right? You can come over here. You can say apt-y install stress. You can spin this box up and like really cause some problems here. So stress-c4. We only have one CPU, so we'll pretend like we have 4. And the timeout can be 180, so we'll do 3 minutes. Whoops. Stress. Gotta spell it right. Stress. So it's going to dispatch those hogs. If we come back over here now, we're going to watch this box start to really be used for CPU. We'll see our load average shoot up. There's the 1, the 5, and the 15-minute load. You know how I've shown you guys, like you do uptime on a box, and it'll show you how much usage a system has? Well, over here on the load average, you're about to see the 1 minute shoot up really fast, and the 5 and the 15 will shoot up at a much more gradual slope. But the 1 minute's going to shoot way up, and then you're going to see the other ones kind of follow. So you can kind of, I'm going to change this down. I want to see this every 5 seconds. I want to see this quicker, you know. But you can set your refresh however you want as well. So the 1 minute will shoot up, and then the 5 and the 15. 5 and the 15 will be much less of a steep slope because they are sliding over a longer window of data. But you could also look at the same load average data by doing uptime, and you can watch that at a command prompt, but that's very hard to show somebody else. Like if I'm over here, let's just go to my Linux box, and I just say, okay, uptime. And then I just give this to some some user in the environment, and then I go to lunch or something. The hell, they don't know what that means. Look at that. But that and this are showing the same type of information. This is the 5 and the 15-minute load average, but that's way easier to read. The data is different because I'm in a different system, but my point is, like, not everybody, one, not everybody can do command line, and two, not everybody wants to do command line. In fact, I would say a lot more people don't want to do command line than do, and then of those people, less of them are capable of doing it than, and that's not some elitist thing. I'm just saying, I think a lot of people just don't even want to work at a command line, right? So you'll find that if you're a systems person, if you like doing if you like doing stuff at the command line, you already got an advantage over all those people that don't, as far as getting in that space. But also, then, you know, we have a lot of resources and other people do to get you doing this stuff professionally. So, all right, where are we at here then? We got this part of the lab done. How do you see yourself applying this? I don't know. I could see a lot of the information out of the system, right? Where do you go from here? What do you know that you didn't know before? Where can you immediately utilize this knowledge and apply it? You could build little labs and test them. What additional topics do you now plan on studying to help solidify this knowledge? Maybe you wanted to learn some of your basic system tools better so you could understand how they relate to what you're seeing in the systems visually, right? And how can I figure out how at a command line to see these same things, right? I know I can do this with uptime. This stuff I need to use probably IOStat to see a lot of this stuff, right? But if I can just see it visually like this, the tool is still very important for us as engineers. But this is something I can give to my network operations center, my NOC, and the NOC can go and do it. Look, that's the last 3 minutes. Now it's all done. Now you're going to see them start to gradually go back down, right? The 1 minute time is going to slide over that window and be finished much quicker than the more gradual sloping ones, right? All right. Where do you go from here? That's that whole part of the lab there. Let's go back over here, and we'll let that keep running. Trace data, that's what we were doing. There's our lab on tracing. And then our summary is, like, we talked about how we monitor systems, right? We do telemetry, which are metrics that are single data points of typically discrete, not quite integer data, but discrete data. Then we have logs. Logs are immutable events that are happening in the system that we want to throw off somewhere. And then tracing tends to be how the data is flowing through the system. But again, in this lab, we didn't really do as much of that, right? Kind of went a little easy on that. Then we did all of these different pieces and built all of these different things out, and showed kind of what was going on in the system. I gotta write from Python to Prometheus, and then that'll be easier to see the trace data, I think. But I need to write that up still, so I haven't done that. All right, so where do we go from here? Does everybody here know what a cottywomple is? This is one of my favorite little things. It's to travel in a purposeful manner towards a vague destination. This is what happens right here. Cottywomples are what happens in projects and other things where we don't want. This is how a lot of people kind of live their life. They just kind of wander wherever. This is how a toddler walks. You ever seen a toddler walk like they know where they're going, but they don't? That's what a cottywomple is. So where do you go from here, right? There's into the cloud. Do you want to get real granular on your telemetry and reading of things? And you're like, okay, Scott, but all those ways you started, I want to start even more. I want to get in there. There's an open telemetry project. And then Grafana has its open telemetry implementation. So Grafana has a lot of good information. By the way, I'm not going to link all these to you guys, but these are in the links. They're up in the Discord. And then do you want to go into Kubernetes in the kernel more? Do you want to look at ebpf.io? Do you want to go into like falco.org? And Falco is a tool that you can use to read how Kubernetes is making syscalls down into the system. The guy who wrote Falco is the same guy who wrote, well, it was Wireshark originally, but now it's, then it was Ethereal, and now it's, now is it Wireshark? Hold on. Look at my system here. I think I got that backwards. Yeah, it's Wireshark now, but it used to be Ethereal, right? And that guy is the same guy who wrote Falco, same organization. And then do you want to go more into log analysis? Do you want to go down into the LogQL analyzer and figure that stuff out more? There's all kinds of places for you guys to go here. There's all kinds of things that maybe interest you in this space. And then there's a lot of places that you can fit down in. I'll tell you, hold on a second real quick. Anytime that happens, I got to restart, discard, restart. Okay. You guys were missing, my voice wasn't, I wasn't getting the closed captioning. One of our guys is coming to talk to us on ebpf.io. So I've got an event coming up. I'll be posting this in the Discord, and I'll be making it a bigger deal here. But August 3rd and August 4th, we'll be celebrating our 5-year of Professional Linux Users Group being on Discord. But we'll be celebrating the 10 years of the group running. We've been running this group for 10 years. We've helped a few hundred people get into the systems engineering world. I think over the last 5 years, we've helped a lot more, especially since I've been streaming. A lot more people have been coming in. But we've helped, people have gotten jobs. People have networked with other people and gotten jobs. And it's just, it's a place to come and work on system stuff, right? But for this one that's coming up, August 3rd and 4th, I'm going to be, I've enlisted some of the other engineers and architects that we have. We have the one guy who's going to talk about ebpf.io. He's a Red Hat certified architect. And you say, what the hell's an RHCA? And I say, when I say that, people are like, do you mean he's an RHCSA? I'm like, no. Pessa got his RHCSA and his RHCE. He scored 100% on both of them. And then he went and got 5 other Red Hat certs, and then you get the architect designation for, I think his is for infrastructure. There's a whole bunch of different architecture ones. He's going to come talk to us about ebpf.io that day. And it's going to be like a little virtual conference that I'm doing. So this is my first time really telling any of you guys about it, but that's going to be like a big virtual conference thing that we're going to do. And you can just come and it'll be down Discord, and it'll just be hang out and talk with the different people. I've got one of my friends is a professor over at UC Irvine, and he's going to come talk data science and data analytics. One of our guys that's been very popular, like people love when Jared comes to talk. He comes and talks Google Analytics and Google Tag Manager, and he tells you about, because he tracks data for users on web pages. That's all he does. That's his professional thing. He does it for a big company that's I think they're $1 billion a year web service company and stuff. So I've got these guys coming. We've got time slots set up. I'll be posting that stuff down in the Discord, and I'll be talking about it here a little bit, but we're going to have a lot of that stuff for you guys to kind of do. And then let's see, what does this end with? I think this one just ends with, yeah, if you got any questions, ask them in the Discord. I have a little section of the Discord. If you have anything, any questions from anything I did or some process you saw, and you're like, shoot, how did he do that? On the Twitch side, you can clip it and send it to me there, and I'll try to answer what I was doing. Yeah, it'll be August 3rd and 4th. Yeah, I'm gonna put it. That should be a Saturday and a Sunday, and I've got like 4 1.5 hour time slots through there, and they're all just gonna be free we'll be down in the chat channels and stuff for people to come and hang out and talk. So that's kind of my goal there. All right, let's get out of there. We did all the labs we needed to today. Let's see, I'm right at 3 hours, so that's probably about where I'll stop here. I've got to do some professional work. I've got some stuff I'm doing with some OpenSCAP and some hardening of systems. I got to go mess with those a little bit. So I'll be doing that here. Like I'm going to be working while I watch Netflix and stuff for the next little bit because the wife's not home for a couple hours. I probably won't hop back on the stream anymore today, but I might. And if I do, I'll just be around and you guys can watch it, and you guys can watch it later on YouTube if you want or whatever. But this was our monitoring deep dive. All this stuff is up in the Discord, and hopefully it was kind of useful to you guys. So I will go to our little end of stream thing here, and we'll go raid somebody on the Twitch side. On the YouTube side, unfortunately, I don't have anything cool like that for you, but we'll go raid somebody on the Twitch side. And who's doing stuff right now? Who am I following that's online right now? Rob's on. Do we want to raid Rob? We might not want to bug Rob when he's doing his boost, because we'll get in there and just go kind of crazy. Let's go look at people in the same category as us, and who's doing interesting stuff over there. I know any of these guys? I don't know anybody over here. But we'll go hit somebody's doing a Raspberry Pi power monitor. That might be kind of fun. Hi, handyman. We go hit him up. Yeah, let's go hit up he's doing Raspberry Pi, and it looks like he's monitoring with Grafana, so we'll go hit him up. I think is he online? No, he's not a real person. No, we're not gonna go to him. We'll go hit somebody. I don't know any of these guys. I don't know anybody here. Hero Dev? Let's go see who Hero Dev is. I don't know this guy. Alright, search and filter. Hero Dev. Alright, we'll hit up Hero Dev. Even though he's in a different thing of us. He's over in software and gaming. We'll go see what he's doing. So, I appreciate you guys coming. I will talk to some of you guys here later on. Or I'll be down in the Discord hanging out most of the day. So, alright, take care everybody.